Hi, my name is Andreas, and in this video I will show you how to start creating a small game from scratch in Unreal Engine 5. We will use some of the latest features but also established workflows from previous versions. We will build a small top-down game and import static meshes, textures, building materials, importing skeletal meshes and animations, and build a small interactive system and do a little bit of polish at the end. So let's start by creating a new project. When you open Unreal Engine 5, it presents you with the new templates you can start with. So they contain new mannequin, Manny, and Quinn. But in our case, we will start with a blank project and just call that first game.
Come on, Unreal. Come on. You can do it. Anytime now. Come on. There you go. Where'd it go? Oh, there we go.
Everything we are building
Curious, they don't have starter content selected, which is interesting, but sure. I think everything else should be fine.
here I do in real time, and when I speed up time I will tell you. Sure, it's recorded in pieces to create a better flow so you can follow.
Excuse me? Neat. We have disk space, is that why? If it happens again, then we'll consider something that it's probably something on my side. Probably not theirs. Okay, so it looks like it created the project. Let's see if it does that again. What the? Okay. Just out of curiosity, let's try loading one of the other ones. Okay, so that's back. Why are you crashing? Yeah, there's Jeff. Just for kicks, let's try loading this new one. haven't loaded this one yet. Okay, and so that loaded. Okay. So why did the other one not load? Or maybe we try and make a new folder? Launch a new game? Or new project? Yeah, it doesn't like that. I don't know what I'm doing wrong. Just out of curiosity, what happens if we do that? No, it doesn't. What the heck? There's a crash when opening new project. Let's see, this is a year ago. Show. Video driver? No. Well, it's just out of curiosity. I mean, we're trying to do this in the newest, latest, greatest, whatever, but what if we do a different version? Okay, that works. I don't know what's up with the other one. Alright, fine. I think we'll be able to continue with this. Sure, whatever.
I'm using the assets from a StackoBot sample project you can download from the marketplace. So here we are, and when you have the project open the first time, you can see this new map here, which is already set to word partition and has a pretty nice real-time lighting setup. But in our case, let's start a new map, and we don't use the existing ones, but we just do a completely empty level. Before we start, let's go through the new UI. Here's a viewport with our scene, and here's the outliner listing all things of our scene. Below are the details of what we have selected. Up here are different modes like select, landscape, and foliage that we can use later. This is the create menu with all kinds of actors we can place, and the green button starts your game. The view modes and show flags allow us to investigate our scene. Down here is a content drawer with a folder structure of our game. Allow us to investigate actors we can place, and the green button starts your game. The view modes and show flags allow us to investigate our scene. Down here is a content drawer with a folder structure of our game that you can also open up with Control Space in all editors. With F10 you can toggle the sidebar. Let's bring in our first actor. We could navigate through the menu or just start typing. Let's
not just a sidebar, it's everything.
Here it is, even if we can't see it. Just start typing. Let's bring in our first actor. We could navigate through the menu or just start typing. Let's select the simple sphere. Here it is, even if we can't see it. It's in the outliner, and also in the details panel you see the properties. When we switch the view mode to unlit, we can see it there. So let's make some light. We will use the environmental light mixer to fastly set up some lights. By creating directional light, we will use the environmental light mixer to fastly set up some there. So let's make some light. We will use the environmental light mixer to fastly set up some lights. By creating directional light, you can now begin to see the sphere. Mixer to fastly set up some lights. By creating directional.
Okay, so atmospheric light.
Light, you can now begin to see the sphere. We can directly change the values like the intensity, and with Control L we can change the angle of our light so it comes a little bit from the front. This is real-time lighting by default. In the project settings under rendering, you can find the settings. New projects use the new global illumination system, Lumen. So let's add some more. An atmospheric skylight, So let's add some more.
Skylight.
An atmospheric skylight, the sky and atmosphere, the new volumetric clouds, and a height.
Cool, all of them, got it.
We also want our atmosphere light fully real-time, so we check real-time capture.
Atmosphere light real-time capture on the skylight. Skylight instance, light, real-time capture. Oh, I'm in world settings. Real-time capture. Got it.
In the skylight. The actors got all spawned at 000 in the world and are a bit hidden. So let's line them up a bit so we have a cleaner scene and don't lose the overview. Let's spawn at 000 in the world and are a bit hidden. So let's line them up.
I don't think that's going to be particularly of much matter.
A bit. So we have a cleaner scene and don't lose the overview.
Oh. Oh, right. Gotta mess with that. I'll figure out a way to make that just like where was it? Invert middle mouse pan. Oh, so much better. Jesus.
What we also can do is creating folders in the outliner and move our actors
Pretty sure that this doesn't matter one bit, but cool.
For the light setup in there. Projects can very fast, get very messy, and some housekeeping from the start can go a long way.
Alright, you did that the hard way, but I know you can do this. Oh. Boop. Alright, double clicking a folder doesn't work, really? Okay. Oh, okay, slow click. Got it.
Okay. Next, let's save our map. Again, let's keep it clean, so we want to do a new folder calling it maps and save our save our map as Valley. When we now take a look in the content drawer, you find this folder structure. Now we want to bring in our first own asset. In the content drawer, we will create a new folder and call it props. That will contain our meshes, materials, and textures. Pressing import, let me choose an asset I want to bring into the engine. SMCreate is an FBX that was created in Blender, but you can use any DCC tool or get them online like from Sketchweb. We don't change any defaults and we want to create the materials.
No, this. Props, I think. Does that matter?
From Sketchweb. We don't change any defaults and we want to create the materials. After pressing import, our static mesh got added as well as the 3 materials this FBX uses. With double click, we open this mesh in an own editor. FBX uses. With double click, we open this mesh in an own editor. Let's dock it up here. On the upper left, you find some numbers about the mesh and the details contain 3 material slots. This button leads to the location of the asset.
Happened?
Let's open.
Is that? Oh, no way. Oh, interesting. That's supposed to. Huh. Okay.
Let's dock it up here. On the upper left, you find some numbers about the mesh and the details contain 3 material slots. This button leads to the location of the asset. Let's open the material editor. On the upper left is a preview. This button leads to the location of the asset. Let's open the material editor. On the upper left is a preview. This button leads to the location of the asset. Let's open the material editor.
Okay, so they're opening for plastic.
On the upper left is a preview. Below are details. Most space takes a material graph where we find this big output node where we can connect nodes to. For example, this one is color we can change. When we hit apply, we can see the result on our mesh. We can zoom in a bit to see how the material is looking from different angles. Let's go back and improve this a bit. When holding 1 and doing a left click, you can create a node with 1 value. We can connect this to roughness of the material and the preview is immediately updated. Value. We can improve this a bit. When holding 1 and doing a left click, you can create a node with 1 value.
Hold 1 and left material. Oh. Okay, interesting.
We can connect this to roughness of the material and the preview is immediately updated. Hit apply again to see how this glossiness looks on the grade.
How do I make this? Is there any way to make this? Okay, well, this is what it is.
Let's make it more interesting by importing textures. So we can import 2 textures here, grayscale grunge texture and a normal. So once here, importing textures. So we can import 2 textures here, grayscale grunge texture and a normal. So once this is imported,
Okay.
texture and a normal. So once this is imported, we will find it in the content drawer.
Oh, I was in the... Also, that's all messed up. I gotta move. here? Okay.
And can drag in the normal and connect that to the output. We will find it in the content drawer and can drag in the normal and connect that to the output pin.
Seems straightforward enough. I'll try and make this a little bigger. I keep wanting to middle mouse click in here. It doesn't like that. Alright. Fine. Normal.
So when we zoom in a bit, we see these nice little bumps here on this material, which we can also witness on the crate if we want.
Ah.
So let's go back and do one last touch until this plastic is done. Let's bring in the crunch texture, and instead of using a fixed value, we use this for the roughness, which gives us this look that it's a little bit touched, which is quite nice. So here we go. This is our plastic material. So let's go to the next one. So next,
Little details.
up is metal. Let's open up this material.
Metal.
And the first thing we want to do is changing the color a little bit. So let's double click here and make that a little bit lighter. Next, we hold 1 again and left click to create a scalar and put that into metallic and change that to 1. Now we have a metal ball. So we do this again now with 0 for the roughness. So we have this really shiny thing. Let's take a look how that looks like on the crate. That's nice. So again, let's make this a little bit more interesting by including some textures we prepared. So we go here and we have a normal again and a roughness. But we will do something slightly different. This time again, we drop in the normal and connect that to the normal output. But if we take a look at that ball, it's again, that's nice. So again, let's make this a little bit more interesting. That's the thing. Let's take a look how that looks like on the crate.
Alright, what did I miss? Metallic, roughness. Is my color just different color than theirs? How high did they go? What is mine?
Next one. Open up. Let's double click here and make that a little bit into metallic and change that. Next, we hold 1 again and left click. Let's double click here. And the first thing we want to do is changing the color a little bit. So let's double click here and make that a little.
Sure. Okay, well now I can't fuss over that.
A little bit lighter. Next, we hold 1 again and left click to create a scalar and put that into metallic and change that to 1.
Ah, that's what I missed. Okay, you're 1. There we go.
Now we have a metal ball. So we do this again now with 0 for the roughness. So we have this really shiny thing. Let's take a look how that looks like on the crate. That's nice. So again, let's make this a little bit more interesting by including some textures we prepared. So we go here and we have a normal again.
Two metals. Alright. Unreal does not like stacking things on top of each other. That's some messed up.
And the roughness. But we will do something slightly different. This time again we drop in the normal and connect that to the normal output. But if we take a look at that ball, it's a little bit too noisy.
Oh crap, which one is which? How do I know the name? You're gonna give me the name? Really? I have to do that? Why did they not put the name anywhere on here? That seems like it's a basic thing that would be very useful. Okay.
For our taste here. So we do a right click and then we look for something called texture coordinates, which gives us access to the UV tiling. So when we connect that to the UVs and then changing the values to, for example, 5 and 5, texture coordinates, which gives us access to the UV tiling. So when we connect that to the UVs and then changing the values to, for example, 5 and 5, we will get something that's more desirable. That's nice. So let's take a look how that looks on our crate. That's more desirable. That's nice.
055. Interesting. Okay. No. Okay, yeah, I see. How do I remove? No. How the heck do you remove a connection? I mean, I could do that and that deletes it. I'm sure there's an easier way.
Nice. So let's take a look how that looks on our crate. That's cool. So let's go to the roughness again, and this time we will bring in the texture we prepared, but instead of using the RGB channel, we only use the red channel. So you can store different information on different channels in
Let's see, red for roughness.
the texture.
Red.
So, and this is our end result.
Rough.
Nice.
That's actually pretty decent. Neat. How do I move slowly? Man, that's fast. Whoa! Okay, I'm being silly.
In the middle, we want to do something like carbon, but a simple setup. Before we do, I want to show you something on the mesh. Here you can check the vertex color of your mesh. We painted some gray values onto the on the mesh.
Demonstrate all our show. OD.
Here you
Show vert colors.
carbon, but a simple setup. Before we do, I want to show you something on the mesh. Here you can
Okay. Something is different. What is different? I wonder if the mesh changed? Or did I do something wrong? Am I wrong or is the file wrong? That's the fun part of tutorials. See, you never know when something goes wrong. Is it you? Or is it it? Well, hopefully the painted UVs is not important.
Check the vertex color of your mesh. We painted some gray values onto the mesh, which we can now use in the material. Let's open up the last material. And again, we start with importing two textures. And again, one is a normal and one is this time one we...
Okay. I have a feeling this is going to go poorly, but sure.
we use for the base color. Let's take a look on the normal for a second, which opens a new editor. Unreal identifies this as normal automatically and sets up the values it's needing. So we have nothing to do here, which is nice. Let's go back to the material and now drag both of those in. First, we add the normal. Again, not the tiling we want. So with the texture coordinate node and some very high numbers this time, we will get much closer to what we are looking for.
80.
Now let's use the grayscale texture for the base color. When we directly plug this in, we can see that we have the same tiling issue as for the normal map. So let's just connect our texture coordinate as well with the UVs for these grayscale texture. Nice. When we now hit apply and go to our create, we can see that this fits very well. Now let's
see. We will see. Okay, so it does look like it's only in the place where it's supposed to. So that's good at least. Wonder why. And no vertex colors. A bit of interesting artifacting there. Oh my god, I've got to be able to slow that down. So bloody fast!
Let's use this vertex color I've shown before. We do a right click and search for vertex color to get that input node. When we multiply this now with our texture output and connect that to the base color, we will now hit apply and go to the create and see our result. So here's our final create with the 3 materials we made. And see our... We will now hit apply and go to the create.
Yeah.
And see our result. So here's our final create with the 3 materials we made very quickly.
So the only thing I could think of is that the at some point they probably lost the vertex painting.
The floor by doing a right click on this sphere. Go to
so I mean, I imagine that it's just a graphical thing. It's probably not going to matter later, but interesting issue with the tutorial.
We made very quickly. Let's bring in the floor by doing a right click on this sphere. Go to made very quickly. Let's bring in the floor by doing a right click.
Replace.
Click on this.
replace with not available. Recently placed. I don't have that.
Fair, go to replace actor and select the cube.
Curious. Cube. Delete it. Huh. Slight little glitch in their tutorial there. It's if you haven't placed a cube, it's not there.
Up here we go to the scaling tool and then we scale it down on that. We scale it up on X and Y. Now we have a floor we can use.
Alright, what have you got? Scale 22, 22, 25.
We bring up the content drawer and drag in the crate we just made.
Nope.
We can move it around and rotate it to see it in our light setup, and we can move the camera a little bit around. We can also change the light again to test how our material reacts to the different light scenarios. And here we are with our first scene done. So now let's talk about logic. When we press play, it seems nothing is really happening. With a crate selected, we can scroll down in the details and select simulate physics. When we now hit play, this crate falls to the ground. The disadvantage is that this is only turned on this specific actor in the scene. If we bring in another crate that looks for the player exactly the same, it will behave differently. Because for this second crate, it's not set to simulate the physics by default. This is where blueprints can come in. Let's create a new folder and call that Game Elements. When opening up the
brain. There we go.
folder, we can do a right click to create assets. We will find a lot of different things, but we will concentrate on blueprints for now. And blueprints can be a lot of different classes, but we start with an actor. And we call that BP_crate. When we open this up, you can see the viewport here in the middle. On the right, we have the details for the components that's selected, and the upper left, we have the list of components. And below we have graphs, functions, and variables. Up here you find the event graph for the game logic, but we ignore that for now. Let's add a static mesh component, which we call create mesh.
What did you do?
Let's add a static mesh component.
Got it.
Which we call create mesh. We still don't see something because we have to set our static mesh crate in the details panel of our added component. So here we have it. The details of this component are identical to the one we saw in our level, including the simulate physics checkbox. We can also tweak it a bit by setting the mass and increasing a bit the linear and angular damping to introduce some drag to this actor.
40.11.
So we save this now and go back to our level. When we now bring in our blueprint we just made, also rotate it a bit, and press play, you can maybe see it behaves a bit differently.
Control Shift S. Donk. Can I not? Interesting. That's going to take some getting used to.
The advantage is when we bring in another blueprint create, it has the same default values we just introduced. And when we change it in the blueprint, all actors in the scene will change too. Now let's replace our floor with a landscape. We can delete our floor and select the landscape mode. This lets me
Landscape.
create a landscape. We do not bother with the details yet and just hit create. Now we have a landscape that we can sculpt, paint, or use landmass tools, but I don't want to cover that. We can change the brush.
It amuses me greatly, just in the sense of, typically a video would say, we're not going to cover that right now. It's just like, no, I don't want to cover that.
Brush size for extrudes, but I don't want to cover that. We can change the brush size. For example, the strength and the brush size and the fall off for smoother or sharper edges. I'm not a very good level designer, so let's try briefly to sculpt something that looks like a small valley.
Alright, I need to get... See, that's that. Yep, that does that. Which means... Yeah, that's still... Which is... big.
Like that. I'm changing a little bit the brush size and then just really fastly drawing something here. When you hold shift, we can also lower an area, like for example here. And then we can use this tool to smooth out some of the roughness we brought in. But yeah, let's keep it like that for a second and head over making a material for our new landscape. Back in select mode, we can select our newly made
Shift 1.
landscape, and in the details we will find the landscape material.
Landscape material. Right there, got it. Okay. Assume we're gonna
So let's make a new material for that. We create a folder named landscape and create a material here which we name name I'm underscore landscape. First, we don't want to have any glossiness on our landscape, so we can search for fully rough in the material settings and it does exactly what it says. So now we have a rough thing. So next we want to add the landscape layer blend node. We can
layer blend. What? This? Is that what you did? What did you do?
So now we have a rough thing. So next we want to add the landscape layer blend node. It says. So now we have a rough thing. So next we want to add the landscape
Gotta be this, yeah.
layer blend node.
Okay.
We can add 2 layers. One we will call sand, and the other we will
Where's it been found? Oh, filter. Okay.
call grass.
Sand and grass.
And when we plug this in now into the base color and we hold 3 and do a left click, we can create a vector node where
Ooh.
we can set the color into like a darkish yellow tone. We do it again, but this time with a dark green. And now we hook this up with the 2 layers. Back in our level, we can add it to the landscape. So you can see it's completely black. Let's fix that by going back into the landscape mode. Back in our level, we can add it to the landscape. So back in our level, we can add it to the landscape. So you can see it's
Landscape material. Oh. Oh.
completely black. Let's fix that by going back into the landscape mode, and in the paint tab we can find our 2 layers we just made. But the information needs to be stored somewhere, so we need to create a weight blended info made. But the information into the landscape mode landscape. So you can see it's completely black. Let's fix that by going back into the landscape. So you can see it's completely black. Let's fix that by going back into the landscape.
So admittedly a little roundabout compared to some of the things I've seen. Layers. Why are my layers not there? Oh. No. So. Layer grass. What did I do wrong?
Landscape mode, and in the paint tab we can find our 2.
What am I doing wrong? Landscape material and landscape. Why is mine not showing anything? Is it not saved? But even it says save all, not do an apply? That could become very annoying. I must have missed something.
Layers we just made. But the information needs to be stored somewhere, so we need to create or 2 layers we just made. But the information needs to be stored somewhere. So we need to create a weight blended info layer, and we do that for the sand in our landscape folder, and the same for our grass.
Okay.
So with this done, we can select those layers and begin to paint here. Again, a reminder that this part isn't really my strength, but I will try my best to paint in some grass.
Seems great.
You can use the same brush settings as for the sculpting. I think this is enough and that works for us now. We can hide my simple drawings with some improvements on the material. So let's import some more textures. Here I have
Okay, what did you do?
2 tileable textures, one for sand and one grayscale, one for grass.
Okay. Got it. Oh, those are in the wrong. You really gotta pay attention to where your grass and sand move.
So we can remove the sand color node for now, but I will keep the green. We can connect the sand and bring in this grass. And when we hit apply and check out the level, we can see that we have sand here and this very beautiful grass. But the tiling isn't very nice. So let's get back to the material and fix that. This time we will use an absolute vert position node, which gives us X, Y, and Z on a given location. As we do not need Z, we will use a component mask to get only 2 coordinates and not 3. R is X, Z, which gives us... This time we will...
Oh, world position. Got it.
Use an absolute vert position node, which gives us X, Y, and Z on a given location. As we do not need Z, we will use a component mask to get only 2 coordinates and not 3. R is X and G is Y in this case. Now we can divide that by a number to control the tiling. For example, 200.
Huh. What if because a new version, this is all that's needed? Let's see if we can skip that.
$56 could work.
256.
And now we plug that into the UVs. And now when I move around, you can see this is word aligned, even in the editor. I really actually like that a lot. So let's copy this part and do the same for actually like that. And now when I move around, you can see this is word aligned, even in the editor. I really actually like that a lot. So let's copy the word aligned UVs. And now when I move around, you can see this is word aligned, even in the editor. I really actually like that a lot. So let's copy this part and do the same for the grass. I'm copying it because maybe we want different values for now. So here, let's try like 512. So when we hit apply and go back to our level, then we can see the result. So let's get rid of this, go to manage for now, so we don't have the brush. And here we are. So here's our textures, and the tiling is not too bad, but the grass is not what we want. So let's go back here and switch that back to 256 for now. And now some cleanup. So there's a very nice new node in Unreal Engine 5, which is called named reroute node. So we call that sand, and now we can unplug that. And in the layer blend, we use this as input. We can unplug that, called named reroute nodes.
Named reroute node. That sounds cool.
So we call that sand, and now we can unplug that. And in the layer blend, we use this as input.
That's cool. Okay. That's pretty neat. I like that. Now the real question is, can you do something like, hey, I need to go yep. Just go find it.
So that's pretty neat. We
That
can do
it
the
is.
same for the grass. But before we do that, let's bring some color to the grass. So we can hold L and do a left click. That brings us an alpha lerp. And we can use a grayscale and this green here. Let's make a copy of that and do a second green, which we in this case make a little bit brighter. And with this plugged in now into our alpha lerp, we can lerp between those two values with the grayscale. So, and when previewing this, this is what it looks like. So now again, we do the named reroute node, name that grass, and also color that green. So it's a little bit better for our overview. And also now values with the to our alpha lerp, we can lerp between those two values with the grayscale. So, and when previewing this, this is what it looks like. So now again, we do the named reroute node, name that grass, and also color that the named reroute. When previewing this, this is what it looks like. Those two values with the grayscale. So, and when
How do I preview the selection that I've got? Previewing. Preview material, show. Why is... Still don't know how to do that. That's cool. AFK a minute. why I'm not getting the preview that they're getting, but... They don't even have the... Oh, start previewing. I wonder if that's... Did they click that?
We can lerp between those two values with the grayscale.
Aha! Okay. Okay.
Okay, so, and when previewing this, this is what it looks like. So now again, we do the named reroute node, name that grass. And also color that green, so it's a little bit better for our overview. And
wait,
now
wait,
color that green, so reroute node, name that grass. And also color that green.
Whoa. Oh, I see. Wow. That's cool. Okay.
So it's a little bit better for our overview. And now we can plug this into the layer. So this is a really nice way to keep your graph clean. And very often it's the small things that can make a big difference. You could also make a material function here, but we keep it like this for now.
Okay, that's pretty cool. Right, save files, Control-Shift-S. Does it actually work? Do I have to go and apply? Yeah. Interesting. So save all is not apply. Apply change to original and use it. Okay. So you literally have to hit apply. That's kind of annoying. I kind of get it, I guess. But, alright. Neat.
So, and here's the result on our landscape. So when we get closer, this is pretty nice and actually what we wanted. So next, let's try to populate this with some grass and some rocks. First, let's spawn some real grass. Before we start, let's change the light direction a little bit.
Spawn real grass? You have real grass. Not digital grass, it's real grass.
To make a nice spot here in the middle. And then let's create a new folder we name environment. Here we want to
selection mode, got it. Temp content. Neat. Folder.
import a static mesh from an FBX and another grayscale texture. We keep working with the defaults for now. Mesh from an FBX. Here we want to import a static mesh from an
Environment.
FBX and another grayscale.
Okay.
Texture. We keep working with the defaults for now. When we open up the grass clump mesh, we can see how it looks like. So let's make this grass material very quickly. We remove the color and drag in our texture. Where the texture is black,
Oh.
we want to have it mask out the material. So for that, we need to change the blend mode from opaque to mask.
Masked.
Now we can plug in the texture to the opacity mask. When we check out the grass mesh now, it begins to look like we want. Let's bring some color back. We go back to our landscape and we steal the setup by copy pasting this in our grass material.
What, they get a preview? Ah, there we go.
And then we connect that with alpha and the base color, and if we take a look, this looks nice. So how do we get this?
What did you do? Did you apply? I didn't see you do apply.
And if we take a look,
Oh, they did apply. Okay. Aha!
look, this looks nice. So how do we get this grass into our level? We could use the foliage tools to paint it in, but there's an easier way, and we can leverage our landscape material for that. When we look for output grass node,
Landscape grass output. Okay.
we can add that, and when we select that, we can see there's a grass type we can attach here. So we need that asset. Let's create that asset. We find under foliage.
Asset. Foliage. Landscape grass type.
Landscape grass type, and call that f_landscape grass. After opening it, we can add different grass types, but one is enough for us. So here we add our grass clump. And then we bump up the density and we change the min and max scale a little bit.
Okay. 800. Jitter. Wait. Grass density quality. You don't have that. Okay. Point 1.4. Interesting.
And back in the landscape, we can add our grass type now. So next is a question.
Aha.
Where to spawn the grass. Here's where the layer blend comes in. We know already where grass was painted. By adding the sample landscape node and changing it to the layer name
Simple. Oh, Mer! Hey, Mer! If that man was changed Badger's mode from FaceRig. Wait. Why is FaceRig is frozen? Why is FaceRig frozen? I restarted that and I checked it earlier. Oh, crash. I wonder if that's part of why I was getting issues earlier. I might need to restart my PC at some point. Shall henceforth call me Nicholas_Kane99. Then upgrade min max scale. Customization load. Let's go shoot. Hey! I mean, unless, we're going in the cooking direction. Yeah. Especially where to spawn grass of the... Hey! Hope you're doing well, Mir.
Grass, we are at node, and we know already where grass was painted. By adding this, there's a layer blend comes in. We know already where grass was painted. By adding the
sample landscape layer sample. Why did I not find that? Landscape layer sample. There it is. Okay, just being silly since you were focused. Yeah. Hyperfocus.
landscape node and changing it to the layer name grass.
Layer name grass.
We are actually done. So back in our level, we have now grass. Isn't that cool?
Oh, dude. Okay then. I wouldn't say it looks great, but yep, there's grass. It's armadillos. Okay, grass. Oh yeah, look at the reflections are picking up the grass, because this metal is like a silver metal like that, but as soon as it comes in with the grass there, it's getting the getting that grass color. Yeah. Oh, there's some of the sand color there.
So next, let's get really crazy with some rocks.
Rocks.
We want to import an FPX named flat rock.
Rock.
This
rock. Are you only importing
rock
that
has
one?
over 6 billion triangles.
Oh, they're doing nanite.
So now we want to change our import settings to build nanite. And then hit import. Now I will speed up this video, but I can tell you that importing and creating the data took under 3 minutes, and it's around 140 megabyte big in the content folder. This is done, we can drag our rock into the level. Switching to nanite visualization triangles, you can see nanite in action.
Alright, well, guess we're waiting a little bit. Remember, this one other thing about thinking about it. Pen display again, but the only ones that aren't sold out at 24 and 22 inch, yeah. Those are racy, to say the least. The frustrating thing that I've encountered whenever I try to go back to dealing with artwork and stuff like that is it's like knowing what you used to be able to do. It's like, yeah, I used to be able to do like this quality or whatever. And then trying to get back into it, and it's just not the same. Did it just crash again? Dude, not cool. Alright. I'm gonna restart. I'm gonna go ahead and stop the stream briefly. I'm gonna completely restart my PC, see if that changes anything. Unreal has been crashing quite a lot today, so we will see if that changed anything. So I don't think I ever do real estate. They have a lot of, yeah, they take up a lot of room. Yeah, they do. All right. Okay. It's gonna take me. God, I gotta go and figure out all these tabs and stuff. Probably gonna take me five minutes to restart stream. So I will be back in anywhere from 5 to 10 minutes to try and figure this out. Alright, we lost some progress. We gotta figure out what we lost. So, a little frustrating that Unreal, and the duplication's still there, darn. I updated OBS while I was at it. I was kind of hoping that it might fix the duplication. Clearly, it did not. Oh well. So yeah, I like completely restarted everything, updated my NVIDIA drivers. I tried loading the projects that were crashing, just straight up. Create a new project, crash. Just cannot load even a new project. I tried loading one of those and it actually got me into the editor and then crashed a few minutes later. It's like without even doing anything. I loaded it and then went off to do something else and it just crashed without me even doing anything, just it being loaded. So, kind of being annoying that Unreal Editor is being unstable for me. Not a good sign. Details, performance. Yeah, I'm only using 15% of my memory. GPU's 30%, but I mean, it's not exactly unexpected. Okay. Let's try and figure out where we left off.
A little bit to get a nicer spot here in the middle. And then let's create a new folder we name environment.
So we have our environments folder.
We want to import a static mesh from an FBX and another grayscale texture. We keep working with the defaults for now.
It seems as though it did not save our imports for that. Or I put them in the wrong spot. Oh. No. Yeah. Okay, so it didn't save the imports, which is interesting that the landscape file is still there, but I mean, I guess it's because I created that, but...
From an FBX.
Okay. Which also means the rock one's not there, but we hadn't actually gotten that far, I don't think so. No. Landscape, no. Where are you? Yeah, your environment. Oh, It's pulling from the... Okay, it's pulling from the wrong folder. There we go. Okay. Remember right, these ones were just...
And another grayscale texture. We keep working with the defaults for now.
Yeah.
When we open up the grass clump mesh, we can see how it looks like. So let's make this grass material very quickly. We remove...
Yeah, we gotta do this all over again.
the color and drag in our texture. Where the texture is black, we want to have it mask out the material. So for that, we need to change the blend mode from opaque to mask. Now we can plug in the texture to the opacity mask. When we...
Right. Where did you do that? Oh, it's here. Masked. Opacity mask.
check out the grass mesh now, it begins to look like we want. Let's bring some color back. We go back to our landscape and we steal the setup by copy pasting this in our grass.
Oh. Wow, did that...
We go back to our landscape.
Did I lose all that too? This is M landscape. Oh, M landscape. No? Yeah, it lost all that. Wow. I thought for sure I saved when I did that. That's super frustrating. I gotta figure out. Coverage, yeah. Okay, well, saving's a big thing. Alright, well, let's see if I can remember. Which LARP was it? Is there a... Oh no, that was like a... What was it? 3... Wasn't 3. 3 was... those. No. Alright, I don't remember. We're gonna have to go back to...
Our best to paint in some grass. You can use the same brush that works for us. With some. Here I have 2 tileable textures. One...
Oh yeah, I wonder if those are even there. Those get lost too? No. Okay, those are still there.
For sand and 1 grayscale one for grass. So we can remove the sand color node for now, but I will keep the green. We can connect the sand and bring in this grass. And when we hit apply and check out the level, we can see that we have sand here and this very beautiful grass. But the tiling isn't very nice. So let's get back to the material and fix that. This time we will use an absolute vert position node, which gives us X, Y, and Z on a given location. As we do not need Z, we will use a component mask to get only 2 coordinates and not 3.
Which I don't need
R
anymore.
is X and G is Y in this case. Now we can divide that by a number to control the tiling. For example, 256 could work. And now we plug that into the UVs. And now when I move around, you can see this is vert aligned. Even in the editor, I really actually like that a lot. So let's copy this part and do the same for the grass. I'm copying it because maybe we want different values for now. So here, let's try like 512.
They go back to 256, they say
So when we hit apply and go back to our level, then we can see the results. So let's get rid of this, go to manage for now, so we don't have the brush. And here we are. So here's our textures and the tiling is not too bad, but the grass is not what we want. So let's go back here and switch that back to 256 for now. And now some cleanup. So there's a very nice new node in Unreal Engine 5, which is called named reroute node. So we call that send, and now we can unplug that. And in the layer blend, we use this as input. So that's pretty neat. We can do the same for the grass. But before we do that, let's bring some color to the grass. So we can hold L and do a left click. That brings us an alpha lerp. And we can use a grayscale and this green here. Let's make a copy of that and do a second green, which we...
81, all right. I emerged.
In this case, make...
What did they do to get the lerp?
And we
How did they get the lerp up?
We can hold L and do a left click.
L! So L is to bring it to chat. Face recognition. Oh. Thank you. Okay. What was I doing? Okay, we got lerp.
That brings us an alpha lerp, and we can use a grayscale and this green here. Let's make a copy of that and do a second green, which we in this case make a little bit brighter. And with this plugged in now into our alpha lerp, we can lerp between those two values with the grayscale. So, and when previewing this is what it looks like. So now again, we do the named reroute node, name that grass, and also color that green. So it's a little bit better for our overview. And now we can plug this into the layer. So this is a really nice way to keep your graph clean. And very often it's the small things that can make a big difference. You could also make a material function here, but we keep it like this for now. So, and here's the result on our landscape. So when we get closer, this is pretty nice and actually what we wanted. So next, let's try to populate this with some grass and some rocks.
Save everything this time.
Let's spawn some real grass. Before we start, let's change the light direction a little bit to get a nicer spot here in the middle. And then let's create a new folder we name environment.
Already got that.
Here we want to import a static mesh from an FBX and another grayscale texture. We keep working with the defaults for now. When we open up the grass clump mesh, we can see how it looks like. So let's make this grass material very quickly. We remove the color and drag in our texture. Where the texture is black, we want to have it mask out the material. So for that, we need to change the blend mode from opaque to mask. Now we can plug in the texture to the opacity mask. Let's bring some color back. We go back to our landscape and we steal the setup by copy pasting this in our grass material.
That's what I was
saying. And
saying.
then we connect that with alpha and the base color. And if we take a look, this looks nice. So alpha and the base color and if real. And then we connect that with alpha and the base color. And if we take a look, this looks nice. So how do we get this grass into our level? We could use the foliage tools to paint it in, but there's an easier way. And we can leverage our landscape material for that. When we look for output grass node, we can add that. And when we select that, we can see there's a grass type we can attach here. So we need that as.
Is that right?
Our landscape to paint it in. We see there's a grass type we can attach here. So we need that asset. And when we select that, we can see there's a grass type grass node. Average the foliage.
No.
So
okay, that is right. Okay.
How do we get this grass into our level? We could use the foliage tools to paint it in, but there's an easier way. And we can leverage our landscape material for that. When we look for output grass node, we can add that. And when we select that, we can see there's a grass type we can attach.
We already
so
built
we need that asset. Let's create that asset we find under foliage, landscape grass type, and call that f_landscape grass.
What? Okay, I already have that. And yeah, that already did its thing. Okay. So I go to the landscape. Okay, F grass, there we go. Apply that. Save. Landscape grass map need to be rebuilt. Landscape physical material needs to be rebuilt. Okay. Yeah, grass clump. Show. Clean graph. Preview, hide, stats, platform stats, life update. Hierarchy, homes. Name, grass, landscape. Disable all screen messages to suppress. I don't want to suppress it. I want to actually do whatever it is I need to do. How to rebuild. Alright. Build. No, that's just nice of a Joe. That should not be there. Wait, where did it go? Oh, I have to be in it. It disappears. Landscape grass maps. To be rebuilt. What do I do? It's all from the honest like texture samples. It's the sampler source to save and restart UE5. Cover the script. Why would it have to restart to do that? That seems awfully counterintuitive. Grass maps, grabs physical objects. How do I do that? Build landscapes? Okay. Build, what does it say? Physics material? Okay, so we still don't have...
We need that asset. Let's create, and when we select that, we can see there's a grass type we can attach here.
Yes, there is.
So we need that asset. Let's create that asset we find under foliage, landscape grass type, and call. After opening it, we can add different grass.
Yeah, we did that.
Grass types, but one is enough for us. So here we add our grass clump, and then we bump up. Back in the landscape, we can add our grass type now. So next is a question where to spawn the grass. Here is
landscape. Oh, right. We haven't actually done that.
Where the layer blend comes in. We know already where grass was painted by adding the sample landscape node.
Right. Okay. Landscape layer sample? I forgot what that was. Landscape. Yeah, layer sample. It's gotta be that. Okay.
And changing it to the layer name grass, we are actually done. So back in our level, We have no grass. Isn't that cool?
Apply. There it goes.
Next, let's get really crazy with some rocks.
Okay. So, this is where things went awry. And landscape grass maps need to be rebuilt again. So, shop, landscape grass pigs. Sure, do landscape grass. Did that fix it? I don't know. Lighting's kind of cool, but okay. Okay.
We want to import an FPX named Flat Rock. This rock has over 6 million triangles. So now we want to change our import settings to build nanite and then hit import.
Build nanite.
Now,
import.
I will speed up this video, but I can tell you that importing and creating the data took under 3 minutes, and it's around 140 megabyte big in the content folder.
Yeah, this is where we crashed.
We can drag our rock into the level. Switching to nanite visual.
So we're going to pause that. Let's go reload our background music. Let's try this. Oh, something went fussy. Oh, something's not happy. Alright, there we go. $10 gigs of memory on Unreal now. 11. Pulling like 90% of my CPU. Oh, there we go. Okay. And we're back down to 8 gigs. 9. Okay. Rock. Actually, let's do this. Let's save all again. So now we should be able to drag this in, yeah? I have big rock. Wait. Oh, that's a material rock. Did not want to do that. Undo that, please. After undo that is not what I wanted. I think it just applied that to my grass. I think I just applied that to my grass. It's not what I wanted. How do I undo that? But I can't undo that. Well, let me undo that. Undo history. Let's not save anything. Okay, there we go. Interesting, it didn't let me reload or undo that. Millions of polys in this stupid little rock. Interesting, crazy.
visualization triangles, you can see nanite level. Switching to nanite visualization triangles, you can see nanite in action, rendering only the amount of triangles needed. If you want to learn more about this awesome technology, check out our other videos, including the one from Matt and Galen, where they show you how to convert your existing scenes using nanite.
That's pretty cool, but
in this material
somebody before had shown that, or had mentioned that, how do I turn it off? Oh, I switched to the thing. That just even turning on nanite in your scene just knocks back your performance a ton, or project. Let's see. Anyway.
Do not want. In this material, we do not want to work with the mesh UVs. So first, let's import another texture for the rock. Which is a tileable texture again, and plug this into the base color. And then let's see how that looks like on the rock. So not what we were looking for. So here we do the same as we did for the material, for the landscape, and use absolutely world position, mask that out, and divide this, in this case by a very, very high number. And then plug that into the UVs.
What is your very, very high number? Tell me.
I think we do something like 1024 here. And let's see how that looks like. So much better, but when you look it from the side, that doesn't look really nice. It's really stretched. So instead of masking RMB, we using Y and Z, so to say. So when we apply now and go back, then we can see it's okay from the side, but now our top doesn't look nice. We can use a little trick here. So we are looking for the vertex normal, and here we can check again with a mask, and this time we only use B, which is Z, which is
vertex
looking
normal
upwards.
WS?
And then with lerp
is that what you did?
We can lerp between two different upwards. Mask and this, and here we can check again with a mask, and this time we only use B, which is Z, which is looking upwards. And then with a lerp again, we can lerp between two different textures. One is our rock, so that's from the side, and then we have to bring two upwards. And then with a lerp again, we can lerp between two different textures. One is our rock, so that's from the side, and then we have to bring something else. Something else in our case can be the sand texture we already used. So we plug this in, and that will have the same issue like we had with the other texture. So we go to our landscape and we issue texture we already side, and then we have to bring something else. Something else. One is our rock, so that's from the side, and then we have to bring something else.
GB. XY, GB. So this is going to need another mask then, because they're doing something that is not here. So they want GB. That. Wait. Yeah, okay. I gotta get used to figuring out whatever these things are. Okay.
Something else in our case can be the sand texture we already.
Sand. Landscape, sand.
Already used. So we plug this in, and that will have the same issue like we had with the other texture. So we go to our landscape and we steal briefly our setup here. So we go to our landscape and we steal briefly our setup here.
Texture sample. I mean, in that case, you might as well just copy the whole bloody thing. Okay. So
we could make
some mask goes here. This goes here.
This now a material function when we use this in different materials, but for our little purpose, this is enough to just copy paste. And here it is, our little nanite rock.
Look at that. I feel like something is still off on mine,
So
though.
let's go back to the valley, and here it is.
Yeah, okay. I must have... What have I got? What is mine doing differently? I mean, this looks the same as theirs. What have I got different? RG, epi, XY. Yeah, RG is XY. That should be the same. 256.
Different materials, but for our little purpose, this is enough to just copy.
Yeah, definitely something's different. Oh, look at this. No? No, yeah, there's this all straight like that too. 1024 G B there's X show. This goes to oh. Does that go there?
When we use this in different materials, but for our little purpose, this is enough to just function briefly like we had with the other texture. So we go to our landscape and we steal briefly our setup here. So
there we go.
We could make this now a material function when we use this in different materials, but for our little purpose, this is enough to just copy paste. And here it is, our little, but for our little, could make this now a material function when we use this in different materials, but for our little purpose, this is enough to just copy paste. And here it is, our little nanite rock. So let's go back to the valley, and here it is. And we want to add many of them. So for that, we will use the foliage tool. Here we can add foliage assets, but we don't have one yet. So let's create one under foliage, static mesh foliage, and we will name this f underscore.
Environment.
Or flat rock.
Foliage. Foliage. What did they say, Dad?
Static mesh.
Static mesh foliage. Can't see behind the video. Flat rock.
Foliage, and we will name this f underscore flat rock. After opening it, we can add our static mesh, and let's change some values, like for example the z offset. We also don't want this rock aligned to the surface
-100.
normal, and this rock is big, so it should have collision. So
Aligned to normal is no.
we set that to block all, and it also should influence the light. So after saving that, we
Influence. What did you say? Influence light.
block all, and it also should influence it.
Like distance field lighting? Okay.
Light. So after saving that, we can go back in the foliage tool and add it to our palette. Here we can change the density and the min and max scale. We could also
density 30. Radius, min max.
override other values or do non-uniform
0.3, 0.5.
scales, but let's keep it simple for now. Let's test how that will look like. First, we try to get a better overview of the scene, and then we select the rock to be spawned, and now we can actually begin to draw them into the scene, but that's not enough. More rocks. So let's increase
More
the
rocks!
density.
So they want density 50.
No, that's still not enough. So increase again. And then let's begin to paint. Yeah, that
They really
looks
want
nice.
rocks.
So let's begin to cover the whole valley with rocks. So that looks nice. More rocks. Let's add just a few more rocks. So
just a few more.
We have now a lot of nanite rocks with 6 million triangle count in this scene.
Jesus Christ, that's insane. Okay. Where's my... How did they get to... Yes, paint. Oh, checked. Aha, you have to actually, like, check the bloody thing. Oh my god, rocks. I got this. I don't got this. Rocks. Why not paint there? It really doesn't like to paint there. Too steep? Must be a steepness setting. So many rocks. 6 million each. I say 6 million polys or 6 million triangles? $6 million rocks. Yeah, I don't like that one. Pew, pew, pew. Alright, we have a few rocks.
I think that's good. When we now change the view mode to nanite visualization, we can see the density of triangles, but there is no noticeable impact on my performance. So yeah, that's where we are. Let's get rid of the rock we placed at the beginning and
Shift 1. Goodbye, rock.
Go back to the crate by opening up the static mesh.
Static mesh, props.
Because there we can check nanite and hit apply. This doesn't have much polygons, but as nanite is a general optimization, we can profit from it. Matte goes deeper in polygons, but
Enable nanite support. Save.
as nanite is a general...
Was there an apply on that one too, or was it just... Where did it go? Wait.
Opening up the static mesh.
Did they open the blueprint?
Because
no, they just
there we
the
can
crate.
check nanite and hit apply.
Okay.
This doesn't have...
Oh. It actually... Oh, apply changes. Wow, dude. Interesting. Okay.
Much polygons, but as Nana is a general optimization, we can profit from it. Matt goes deeper in his video about conversion from UE4 to UE5, as does Chris Murphy in his guided tour. Let's add a bit more vegetation. I'm using the assets from the nice sample project Statobot, but this time we want to migrate the trees and the fern from this project to ours. We do so by selecting the assets we want, do a right click, go to Asset Action and then Migrate. We will be presented with a list. Go to Asset Action and then Migrate. We will be presented with a list of all asset references.
So I'd have to... Okay, so I need to open another... I need to open the other project. Got it. Nope, not that. I think. And this.
And then migrate. We will be presented with a list of all asset references. We want all. Now we need to choose the content folder to our target project and migrate. Here we are back. We need to choose the content presented with a list of all asset references. We want all. Now we need to choose the content folder.
Content folder or other. Content folder. Actually, let's just throw it in content. You'll move it afterwards. Okay.
Folder to our target project and migrate. Here we are back, and we have now a new folder with the hierarchy.
Oh, okay. It pulls in the... Oh, I see it.
Key from our source project.
Why does it only have... It's only folders here. There's no files. Come to Stackabot environment. Stackabot environment. Foliage. I don't have any filters on. Okay, something is odd. Because they are on the disk. I can see they're on the disk.
Key from object and migrate. Here we are back. We need to choose the be presented with a list of all asset references. We want all. Now we need to choose the content folder to our target project and migrate. Here we are back, and we have now a new folder with the hierarchy from our source project.
Yeah, but why is yours actually showing the files and mine isn't? What am I missing? What are you doing wrong? In Unity, there's like a re-import thing. Process first shower, quicker shower. What am I doing wrong? Just to prove that I'm not crazy. Do this. No? So, new plugins, 10 assets were open in the editor session. Oh, yes. Yes, I want all of the things. I want them all. Ugh, that's annoying. It's like, yeah, just can I select more than one thing? No. Okay. I want all of them docked here, but fine, screw you. You suck. Day one was all about like, oh, this is really cool. Super excited. Day two is like, okay, let's just show you all of the problems that we have. Why are you not letting me dock? Oh! Wait, hold on. I'm being a derp. This is... Okay. Fin level. Yeah, I'm being a derp. Okay. Got it. Because I was... This is the other... Okay, that's fine. I don't care about you. Because the files are here. Why are you not showing them? What am I missing? Do I have like a filter on or something stupid? Like yeah, so I can see that the U assets are here. Foliage, brush, tree. Yeah, so the U assets exist on file. They're on the disk. But it's not here. Why is it not here? I don't understand what I'm missing.
We have now a new folder to our target project and migrate.
I'm gonna do something. No, first game content. That's exactly what I did. I did the first game content.
Now we need to choose the content folder to our.
Oh crud!
That's where the information is stored. So now we can see the whole report. camera. We do, but we will also let's add a bit more vegetation landscape. And we are Autobot, but this time we want to and then migrate. We will be presented with a list of all asset references that we want all. Now we need to choose the content folder to our target project and migrate. Here we are back and we have now a new folder. With a hierarchy from our source project.
Why is it not working for me? Do I have to actually like import these? That would be really stupid. It's like it's already here. Oh, there isn't even an import option for that because freaking US a bunch. What am I missing? I don't understand. God dang it. Assets doesn't display correctly after migration. Make sure that you also migrate all of its dependencies. Supposedly it should have been. The assets display correctly on the original project. Migrated assets don't show up again. Right click config, fix up redirectors. Fix up redirectors. Just taking a shot, man. And you can also try to. There's some reason show. No. Migrate to the nervous show. Right. So, well, let's try reloading this, I guess, and try the migrate again. I don't know what that would change because all of the asset actions, migrate. Everything is selected. Content, project, Triforce. An asset already exists. Would you like to overwrite it? Yes. Go ahead. All of them. Have fun. Enjoy. Oh, why did they disappear from here? And then they didn't. Okay, now they're back. Oh, dude, what the heck? I'm so confused. I don't understand. What did I do wrong?
This static project and migrate. Here we are back, and we have now choose the content folder to our list of all asset references. We want all. Now we need to choose the content folder to our target project and migrate. Here we are back, and we have now a new folder with a hierarchy from our source project. We have now a new folder with a hierarchy from our source project.
Wait, what? Okay. Oh, okay. They're all new assets. Did I... Maybe I selected the wrong thing?
To our target project and references, and then selecting the assets we want, do a right click, go to asset action, and then migrate.
No, it's definitely what I did. Asset action, migrate. I'm so confused.
We will be presented with a list of all asset references. We want all. Now we need to choose the content folder to our target project and migrate. Here we are back, and we have now a new folder with a hierarchy from our source project.
I have a headache. This is frustrating. It's like, seriously, just trying to do beginner level tutorials that I don't have enough knowledge of the engine to know how to deal with issues. And something goes wrong, I don't know what to do. clearly, I must have done something wrong. But I don't understand what. I'm Cyber US. It's 2 new engine versions. Oh. Be nice if there was like numbers here, like, hey, you've got a bunch of errors. It's 2 new engine version will show, package will show. Okay. That's weird. What's weird? This is the same bloody version of this. Oh, I loaded StackBot in 5.4. And I did this in 5.2. Okay. So... Five two. Content distinguish you. Yes, replace everything. Wait, where did my other... Did I close my other project? I might have closed my... Yeah, I don't want to save anything. Did it crash or did I close it? I don't remember closing it. There they are. Thank God. Why are you not colored though? There you go. Okay, now you're colored. Jesus Christ. It didn't ask me to reload all of my windows this time, though, which is annoying. So either I quit or it... Okay. Okay! Problem solved! Moving on.
Now a new folder with a hierarchy from our source project. This static mesh foliage we can now add in our foliage tool. For example, the fern. We want to...
Wait, where did our other rock... What? Oh! Okay. Landscape. No, foliage. Okay, there it is, the rock's still over too. Okay.
Slightly smaller scale in this
Density 4. 0.4.
level, but we keep the density. And now we
0.4.6. 0.4.6.
we can select them and easily paint them onto our landscape. Maybe some more here.
Okay. Turning on. Looks great.
Just to give it a little bit more color. And we can do the same with the trees. Here as well we want a little bit smaller trees. And as with a fern, we can just paint
Density 1.
a bit in here and
0.51. 51.
until we have some nice trees in our little valley. So
Cool, great, awesome.
now with the fern and the trees, this begins to look like a very lovely scene. But now let's switch gears and begin with the gameplay. Before we start, let's press play and see what happens. So besides our crates falling to the ground, we can find some yellow colored actors in our outliner. Many of them are default actors that get automatically spawned, like for example the game mode or the pawn or the player controller. So those three we want to replace with our own. In the project settings, under game mode, we find the default game mode base, which defines what classes are spawned.
Project game mode.
Defines the default project settings under game mode.
Maps and modes.
We find the default game mode base, which defines what classes are spawned. Also the startup maps are defined here, so let's briefly change that to our valley. And now we want to make an own game mode, an own pawn, and an own player controller. So let's
What did I just do?
create a new folder and name that one framework. In there, we want to create a new blueprint class. We worked only with an actor before, but blueprints can be made out of many different classes. When we open up an actor in our classes, you will find that our crate is a child of an actor. And the character is will find that our crate is a child of an actor.
Where's yours blue? Mine's not blue. I don't know what that means.
And a character is a child of a pawn, which means they inherit functionality from their parent. But we will base on the game mode base and name this one BP game mode for now. We will base on the game mode base and name this one BP game mode for now. Next, we need a character.
Dang it.
Character is based on a pawn and comes with built-in functionality we will use. We will name this one BP bot. So imagine this being the body that runs around in our scene, but we also need a brain. In Unreal terms, that is the controller. We will need a player controller, but we will also look into an AI controller later. We name this simple one BP player controller. Now we have to tie all the three things together and add it to our level. When we open up the game mode, you can see it looks like a normal actor blueprint. We could even have logic here the game mode should take care of. But we will only override some default classes here. First, let's add our player controller here. So instead of default classes here, the game mode should take care of. But we will only override some default classes here. First, let's add our player controller here. So instead of the default one, we want to use our BP
Player controller.
player controller. It also spawns the default pawn class, and our BP bot is a character that's based on a pawn, so we can add that here. Class and our BP bot
Player state admin. Okay.
is a character that's based on a pawn, so we can add that here. So let's save that and close it. Now we have to tell our game to use our own game mode. We could add it to the specifics of this level in the world settings if we would have different game modes for different maps, but here we just want to add it as a default for all maps, so we do it in the project settings. And here you can see there's a BP bot and the character now. Next, we need to define where our character should be spawned in the world. We use the player start actor. The game mode will use it automatically when it
Oh wow, you gotta be careful. Player start. Okay.
it's in the scene. This blue arrow shows us the direction the character will be orientated when spawned. When we use the end key, it will be placed on the ground. So let's find a nice spot to start from. When we now hit play, we will find ourselves at that location. With this button, we can detach from the player controller to get back to the editor controls while the game is even running. And when we now look in the outliner, we can find our BP bot and other blueprints we made. So now we have our basics set up and can move to the camera. We can have the camera in many different places, like in the controller, but we will add it to the bot itself. When we open up the character and take a look in the viewport, we will find different components, like the capsule for collision and movement, or the arrow component that shows us a forward direction. And then there is a skeletal mesh component that we will use later. And the character movement component that will help us move this character around and has a lot of values we can tweak. Let's make the capsule not hiding in game so we can see it when playing. When we now hiding in game so we can see it when playing. When we now press play and detach, we can see the capsule. Visibility is not great in the video, but it will serve the purpose for now. Let's stop and go back to our character blueprint. For
Character shows that at the bottom.
our little game, we don't want to look through his eyes, but we want an own camera that's looking from top down. To do that, we will add a component called spring arm. That will give us some neat options. We could rotate it or scale the arm length, but before we do, let's attach a camera to the spring arm. And now, after that, when we select the spring arm again and change the rotation, we will see that the camera will follow.
Trying to understand what the difference is between that. Like, why would you need a spring arm versus just a nested object? Like an object inside of an object, you rotate it, fits. If the parent's center was here, if its origin is here, and you rotate it, then the camera's going to do that exact same thing. Like that's there's probably just more things you can do with the spring arm. Maybe it's got some actual bounciness follow or something.
Then we want to move it out a bit, so we increase our arm length. Now the camera...
That would be one. Arm length, arm length, arm length. What do they do? 2,000. Oh boy.
Camera is above the character looking down. Let's select the camera and change the field of view of the camera. We do 45 degrees for now.
The camera. FOV.
To get a little bit of an isometric look. The spring arm has some more handy features. It could check for collision to adjust the camera, but we
got
don't
it.
want that
Okay,
here, so we disable that.
That's why spring arm is cool. Got it. So the unchecked collision.
Check out how this looks in game.
Okay.
Awesome, this is actually what we are looking for. So next, let's do some movement. Again, there are several ways to do that. In our case, we want to implement the input the player is giving to the player controller we made. Remember, the controller is a brain controlling our body, which is our bot. As this is our first real logic, let's briefly talk about this event. This
is definitely a different, just wrapping your head around the different concepts of how Unreal treats all these different things. It's different. It's not better or worse. It's just, it's very different. It definitely takes some getting used to. Alright, so we're in event graph on player controller.
Begin play and a tick event. There's actually more. For example, a destroyed event. This is basically the parts every actor goes through in his lifetime. Begin play when he's spawned, tick is updating while he's in the world, and destroyed when he's removed. But we don't need that for now. Now we use print string to display some text on screen. It's one of my most used nodes. First, let's hook it up to begin play and see what it does. So when we press play, you will see in the upper left corner printed hello. Let's do it again in case you missed it. Here it is. So let's go back, stop it here, and then hook this up to tick. So when you now hit play, you will see it's printed rapidly every tick. For that reason, you want to be thoughtful what you do here. Complex things on tick will have an impact. But we want to move our character every tick. As this is a controller and not the character itself, we need to get access to our character. The controller knows what it's controlling, so we can use the get controlled pawn. So this pin is now our pawn we can give orders to, and we will find add movement input on the character. Now we hook this up to the event, so it's get called every tick. Or simply put on the character. So this pin is now our pawn we can give orders to, and we will find add movement input on the character. Now we hook this up to the event, so it's get called every tick. For simplification, let's say this goes to the hooks this up pawn we can give orders to, and we will find add movement input on the character. Now we hook this up to the event, so it's get called every tick. For simplification, let's say this goes to the movement component in our bot. It needs a direction, so let's set the x of the vector to 1. Hit play and witness our actor moving in world x direction until it gets blocked. Now we need to figure out in which direction we want to go. In Blueprints we have access to many things, and this includes the location in the world under the cursor.
Okay,
you can go deeper and have different trace channels, but we keep it for everything that's visible for.
Get hit result under cursor. By channel. Oh, is this... Dude. No way. Maybe? Target self.
Now. Here is a hit result, and as it has many information, we can break this struct to see what it gives us. In our case, we only care for the location. As we now have our location in the world where the cursor is, we need one more, and that's where our bot is in the world. We can do get actor location on the pawn. With this, both locations...
Dude! Okay. If this is doing what I think it's doing, that is ridiculous.
That's where our bot is in the world. We can do get actor location on the pawn. With this both more, and that's where our bot is. As we now have our location struct to see what it gives us. In
break hit result.
In our case, we only care for the location. As we now have our location in the world where the cursor is, we need one more, and that's where our bot is in the world. We can do get actor location on the pawn. With this, both locations...
Actor location. Get actor... Array average location? That doesn't seem right. No. What are you?
And that's where our bot is in the world. We can do get actor location on the pawn.
Get location, transform, get actor location. Focal location. Get actor location. I feel like there's a version difference issue here. But pawn get focal? Okay, so we're trying to the location of player control is focused. Maybe it's under pawn. Target self return value. Target is player controller.
With this
target is actor. Get actor location. That doesn't seem right. Target. Pawn. Controlled pawn, focal and control. Target is local. Something doesn't seem consumer, okay. Get actor location for show. Got it. Okay. Context sensitive. That's was the first result that came up when I tried to search for like, hey, this isn't showing up. Apparently that context search is a problem. Right,
one more, and that's where our bot is in the world. We can do get actor location on the pawn. With this both locations, we can use a vector mask function called get direction. It gives us a direction of a vector from two locations. This is a function called get direction. It gives us a direction of a vector from two locations.
Unit direction vector, okay. So this location, this location. I don't remember which one was right. There was a little guide on suggested blueprint alignment standards, and don't remember what it said to do for this, but oh, okay.
This is exactly what we need here. So the character
Oh yeah, we can ditch that because I don't need to.
moves in the direction where the cursor is.
Okay.
When we now start the game, we will see the bot will be with the camera attached following the cursor. So he's going left and right.
Okay, that's freaking awesome. Wow. Being able to do that easily, that quickly, that's impressive. Okay. That is pretty cool. Must admit, it's pretty neat.
And down and up. Super cool. I didn't click in the viewport when the game was running. If I would have, you would have seen the cursor disappear. Fortunately, the player controller managed that, and we can go to the details and check show mouse cursor. So if I...
Wait, where did you go? So you're in player controller. What do you have selected? Details. What?
The game was running. If I would have, you would have seen the cursor disappear.
Ah, okay, I got it. Show mouse cursor, got it.
Fortunately, the player controller managed that, and we can go to the details and check show mouse cursor. So
Christ.
if I now start the game and click into the viewport, the mouse keeps being rendered and the character following that.
That's
As we
crazy.
don't want to follow the cursor all the time, we need to introduce some player input. To add input, go to the project settings, scroll down to input where we find different bindings we can make. There are axis bindings and there are action bindings. We will only work with action bindings, and you can imagine this like digital on and off switches.
What am I missing?
We will different bindings we can make. There are access
Engine.
bindings and there are action bindings. We will only work with action bindings. And you can scroll down to input where we find different bindings we can make.
Access and action mappings are now deprecated. Please use inhibitor. Yeah.
There are access bindings and there are action bindings. We will only work with action bindings. And you can imagine this like digital on and off switches. Let's add a binding and call that toggle movement.
Okay. So, this tutorial is dated. Because there is now a new input manager in town. I wonder if we can finagle how to use the new one. Let's watch what they do and see if I can piece together some other
We can click
things.
this little icon here to press a key to bind that to our action. Here I do a left mouse click so you can see this is mapped now. Back in our player controller we can remove the begin play for now. And now we can look for the new event we introduced with the binding. We will find toggle input here and add it to our graph. So this has two execution pins. One is fired when it's...
Okay, so if I remember right, as I thought I saw something like this. Thought there was just a straight up input, like click or something. Click method. Mouse position. Get input. Okay, what was that thing called? Get mouse click, touch the merge. Left mouse button, where's it called? Enhanced input, storage. It's default input with energy. Hold. Enhance, it's not related. Enhanced input. Enhanced input, action, new actions. Where did I see this? So I don't know if this is new or old. Left mouse button. Is this new or old? I don't know. Input action, toggle input, press release.
It's pressed and when it's released. So now we only want to follow the cursor while we hold the mouse button down. So to do that, we will add a variable here and call that add movement. This is a boolean, but there are many more variables.
Okay. Movement, boolean. We're going to drag that in, aren't we?
In toggle input, we want to set this variable. So when it's pressed, is fired, we set this to be true. And then when we copy paste that, attach this, when it's released, we want to set this to false. And now we only want to add movement while this is true. So we get the variable, and from here we can look for an if or a to add move this. When it's released, we want to set this to false. And now we only want to add movement while this is true, so we get the variable, and from here we can look for an if or a branch node. With this we can say execute this order only when the variable is true. So we are done. Let's start the game. Only when the variable is true. So we are done.
Event tick. Condition is this. Event tick. Do this, if that, if true, do that. No, no, stop. Stop. Okay. Okay.
Let's start the game. And he is standing around, and when we press the mouse, he's moving in that direction. And he stops when we release the button. So this feels quite nice, and it's the first time we have a feeling of really controlling our little capsule here.
That's cool.
Just moving a capsule around is kind of boring, so let's get an animated character in. Back in the character, we had the skeletal mesh component. We want to use that instead of drawing our capsule here. So to do that, let's create a new component. We want to use that instead of animated character in. Back in the character, we had the skeletal mesh component. We want to use
to go.
that instead of drawing our capsule here. So to do that, let's create a new folder and call this character. And here, let's import the FBX that contains our skeletal mesh. In the import menu, you can see Unreal already identified it being a skeletal mesh and ask for import menu. You can see our skeletal mesh.
What are you grabbing? Got it. Projects, source files. Character, you're grabbing this.
In the import menu, you can see Unreal already identified it being a skeletal mesh and ask for a skeleton. In our case, it's the first skeletal mesh we bring in, so we want to have import mesh checked.
Import mesh, okay.
What we don't want for now is automatically generate a physics asset.
Automatically. Oh, is that under? What did you uncheck?
We want to have import mesh checked. What we don't want for now is
create physics asset. What? Mesh advanced. Create physics asset. There you are.
Automatically generate a physics asset. The rest we leave it like it is, and then we hit import. When we open up our character folder,
problem. File show found name class show was renamed as show. Okay. Strange, but okay. Sure.
now we can see different assets that got created. We already know about the materials, but we have a skeletal mesh and a skeleton.
Skeleton. Yours is different than mine, but okay, hopefully that.
Let's open this.
Oh, that's the one we're going to open. All right.
The skeleton that got created from the mesh has all the hierarchy of its bones. Let's show the bones for a second.
Show your bones! How did you do that?
The hierarchy of its bones. Let's show the bones for a second.
Oh, character. Bone. Oh, hierarchy.
Second. Most animation assets will need to reference one skeleton. So the second asset we have here is the skeletal mesh. You can see this as a skin, so you could have different meshes using the same skeleton. It contains data like the material slots, LOD settings, post-process animation blueprints, and more. As we don't want this robot to be gray but more colorful, let's make his materials quickly. It will not be massively different from what we have done before, but he comes with some more text.
What did you just do?
It will not be massively different from what we have done before.
Oh, so you just click it?
Quick.
That's what you do?
And
Alright, what is that? Bot base? No? Dude, what did you do? What did you do?
some extra nice things for his face. From what we have done before, but he comes with materials quickly. It will not be massively different from what we have done before, but he comes...
How did you do that? Ah! Alt click. Can I do that on the thing? Oh, you can just do it anywhere on the line. Alt click. Oh my god, I was looking for that. Hey!
Comes with some more textures and some extra nice things for his face. We have done before, but he comes with some more textures and some extra nice...
Got it. Bot. Oh, it just straight up there. There's no import.
things for his face. First, we import all textures. It comes with a gray...
Oh, all textures.
And some extra nice things for his...
Got it. What happens if you do that again? Didn't seem to care. Good. Textures
face. First, we import all textures. It comes with a grayscale albedo, an atlas for facial expression, masks, and a normal map. We start with the albedo, and we just plug this into the base color. And then when we take a look at him, it's still gray, but a little bit more interesting. So now let's add color. We use a blend overlay node, and then
blend soft light
to the
no blend
base
overlay.
color.
Blend overlay, okay.
And use the parameter here.
Can you do this? No. If I remember right, Unity has that in their shader graphs, which is pretty bloody useful. It's like, hey, there's a line here. I want this to go in between it. Granted, it might only work when you actually have something that's obvious. Because how would it know what's going where? So I guess I'm sure.
Here. And now let's find a nice color, like for example, a bright orange. So when we look back in our characters, this is what we got. Now let's take a look at a texture. So this one here. So in the texture editor, so this one here. Take a look at, we look back in our character texture editor. So this one here. So in the texture editor, we can display the different informations in red, green, and blue channels. Here we save metal.
How did you do that?
We can do one here. So in the texture editor, we can display here. Take a look at a texture. So this one here. So in the texture editor,
oh, they're up there. Oh, my glasses are really messing with this color scheme here. Oh, that's so weird. Okay, interesting. I don't know why I can't toggle blue on and off.
We can display the different informations in red, green and blue channels. Here we save metalness in red, in green have roughness and blue has the ambient occlusion. So back in the material we can bring in this and connect metallic, roughness and AO to the different pins.
That's cool, using one image for the different things. I never thought of that. Clever. Very clever. Okay, so it goes where? Red was metallic. Green is roughness. Blue is ambient occlusion. Neat.
So after applying that to our character, this is already a nice leap forward. This like this pathetic look on his arms. But they have the wrong color, so let's fix this. We can use the mask texture and again a lerp node.
Okay. That's a shame. Okay, what was that texture you just did? This one. And lerp.
The green channel separates the orange parts from the metal parts. So one part is orange, and for the other we add another 3 vector node and change the color to a gray. When we hit apply and go back to our character,
okay. So you're that. You're that. This is this. This goes here. This goes here.
this is how it looks like.
Oh, that's cool. Oh, nice. That's neat. God, so freaking fast. Okay.
So some last touches by adding a normal and give him some emissive parts. First we bring in our normal map and connect that. And then we have this mask texture, and that uses the red channel for emissive parts of the mesh.
Alright, what do we do? We have normal and What did they say? Alright, all for stuff. This goes to normal.
So we can multiply this and plug it into the emissive output. And we multiply this with a color.
Okay, so your red goes to multiply. This goes to emissive. Oh. Okay. Boy, this is getting messy really quickly.
For the color, we take a very, very light blue. And if we hit apply and go back to our bot, we see his main body is ready. So the only thing left is now his face.
What is the blue?
So,
oh, is that what was on the... No. What is that? What is the blue that you just did? What turned blue? What was it blue? What did you do? I don't know what the blue was. Yeah.
So for the face, we have one extra background texture. So let's bring that in. This time we will plug this into, let's bring that in. So for the face, we have
a different thing. Okay.
One extra background texture. So let's bring that in. This time we will plug this into the emissive color. And then we will hit apply and see how that looks like on our bot. So now let's add the eyes. For that, we have an atlas here, which is mainly a texture with an alpha masking its different expression, and it's on a 4x4 grid. Okay. So to select the face we want, first we want...
Wait, hold on. Why am I not showing it? Did save all? Why did it not actually save? Okay, yeah, there's the blue. Why? Control-Shift-S. So, Control-Shift-S is not actually saving. That's weird.
To add this texture to our background text. To select an alpha, mask the eyes. So now let's add the eyes. For that, we have an atlas here, which is mainly a texture with an alpha masking its different expression, and it's on a 4x4 grid. So to select the face we want, first we want to add this texture.
Wow. Okay.
So to select the face we want, first we want to add this texture to our background texture. So we use an add, and we can use the alpha channel for that because that's where the information is stored. So now we can see the whole texture added to the other. But we want to control the color. So let's multiply this with the color. And then again, let's change it to a bright light blue. And add and plug this into the ad.
Okay, we did that. You go here, you go there, you go here now.
Now we will use a flipbook to help us select what kind of face we want from that atlas. And we will use the UV output. So already with this default and with this node, we can see some animation and it's shown on a 2x2 face. So let's fix that. We will bring in, and we will use the UV output. So us select what kind of face we want from that atlas. And we will use the UV.
UV goes here.
Output. So already with this default and with this node, we can see some animation and it's shown on a 2x2 face. So let's fix that. We will bring in the scalar parameter and change this to 4 because this is the amount of rows and columns we have. So we can just plug this in here and here. And now it is
number of rows, number of columns.
Running through this like an animation. So if you want to animate a texture, this is a nice way, but we
dude, holy cow. Like, yeah, just animating textures like that. Oh my god.
We want to set it to a fixed value. So let's bring another parameter, and when we're changing that, we can change the face. But in our case, we will keep the standard one, very simple like this. So hit apply, and then we are done, and we have very simple like this. So hit apply, and then we are done, and we have our.
Okay, so this is saying that all is saved. Everything is saved here, according to this. Even though I'm changing something, changed it, all is saved. It's wrong. It's wrong. So if I hit save, now it's actually saved. So that's interesting. That's cool.
Our character with a face which we could animate if we want. We will add him to our bot and do some movement adjustments. Here in the bot, on the schedule mesh, we can.
Okay. Where are we? Oh, bot. On mesh.
Can add him now. Do some movement adjustments. Here in the bot, on the schedule mesh, we can add.
Oh, yeah, okay. Skeletal mesh. You're in my way. Boom. It's gonna be wrong.
Him now. So here it is, but it's a bit in the wrong location on rotation. Let's fix that. First, we rotate him 90 degrees.
Yep. On the Z. Negative 90 on the Z.
So he's facing in the forward direction of our character logic. Next, let's take a look at the capsule. That's a little bit too big for him. First, we change the radius to
capsule.
Be a little bit smaller, and we can probably reduce the height a bit.
Alright, what are we looking at? 2570. 25.
So back in the mesh, we can change its relative Z location so it fits into
70.
to the capsule. So now we have a capsule that represents him a little bit better. It all depends on your needs, but for our little games this is okay. So when we hit play, we have the character and it's moving around. Nice. But we can see some issues.
Cool.
Most obviously, he's not facing in the direction he's moving towards. So back in the bot, we can select the movement component, and here we can search for rotation, where we can find orient rotation to movement.
No way. Rotation, orient rotation. Jesus Christ, it's a freaking checkbox.
We can also increase his speed, how fast he's doing that. So
420.
So with this done,
Jesus. Okay, something's not right. Oh, wait, no. Okay.
will face in the direction he's moving to, but
No,
so
I don't. Why not?
done.
Rotates that round and round. Well, playing the sounds, yep, spin me round and round. Okay, what did I do wrong?
And also where we can find orient the movement component, and here we can search for rotation, where we can find orient rotation to movement. We can also increase his speed, how fast he's doing that. So with this done, will face in the direction he's
Let's
doing
see.
that. So with this done,
It's on character movement. It's on the bot. Bot self, character movement. What is... What did I miss? Why is it wrong? Okay. What is wrong? What is wrong? Orient rotation of movement. What is this one? Okay. Is that literally on the same thing? Yeah, okay. Okay, so we're not getting any crazy jittering, but as soon as I do this, is very much not happy. Orient to.
Also increases bind, orient, rotation to movement. We can also increase his speed, how fast he's doing that. So with this done, will face in the direction he's moving to, but so does the camera. We can easily change.
Except it doesn't. Why? What did I get wrong? All right. Hold on. Our base rotation, that's the same. Show. Oh, physics. Said 420.
That. So with this done.
Wait. Why is no?
Increases speed, how fast he's doing that. So
Yeah, I don't know. Not sure what I messed up with there.
So with this done, will face in the direction he's moving to, but so does the camera. We can easily change that by going back to the spring arm, and there for the rotation we can switch from being it's set to relative what it's attached to being set to vertical. So when we now being it's set to relative what it's attached to being set to vert aligned. So when we now hit play, it is looking like we
So it's... I don't know. It's weird.
and
so
this
something's still
is
wrong.
beginning to feel like a real game. So he's following the cursor and the camera stays fixed and he follows it. Animations are missing, but before we do that, let's go back to the character movement and make some changes. For example, how fast the bot can accelerate. The next thing is we also want to increase the maximum. The next thing is, for example, how fast the bot can accelerate. The next thing is
500.
we also want to increase the maximal step height and a little bit the angle he can walk on. We want to set his maximum speed to 400.
Okay, 60, 60, 400. 60, 60, 400.
And for now, we will decrease the ground friction and also reduce how fast he is stopped when no input is given. And we will do all that so he is slower given. And also reduce. For now, we will decrease the ground friction and also reduce how fast he is stopped when no input is given.
800.
And we will do all that so he is slower accelerating and not immediately stopping when no.
Okay. Okay, that seems to kind of work. Spider Sniper, heyo! How you doing? It goes, okay. Had multiple crashes today, and a couple instances where the tutorial is outdated, and a weird issue that I don't know what the solution for is right now. The current state of the tutorial is that the bot should be rotating with the cursor, but it's not. I don't know why. First ever using Unreal 5 for the first time. Me too. Well, technically second time because this is day 2. Are you coming from any other engine? Do you have any other experience? Do you have background programmer experience or anything like that? Where are you coming from? 'Cause I'm very new to it, but there's some really good tutorials. Yeah, lots of good stuff. You just found it. Ah, very new. I would highly recommend. Where is it? Tutorials. Let me pull this off on the side. Okay, let me go back a page. Gotcha. Learning Epic Games. So if you want, since we're new, could learn together if you want to make things easy for us. I mean, we're probably going to be learning at different paces because I have very set times where I do stuff, but I am more than happy to like bounce things back and forth. It's like, I don't remember how to do this, or I don't know how to do this, or whatnot. Like, by all means, please do not hesitate to ask questions. I'm probably not going to know the answers yet, but yeah, happy to do what I can. I'm giving you a tip that I liked, though. I wonder if I can copy the URL. I want to do this. Give me 1 second. Courses, learning paths, trainers, not that, and for beginners. Yeah. Courses, learning paths, tutorials. Yeah. Okay. It seems like it is actually copying the, well, so don't just right-click copy the link, like copy the whole text and put that in. But this learning library, specifically done by Epic Games themselves, like, so these are effectively official tutorials, which is pretty cool. The learning paths that I started was like your first hour in Unreal Engine 5.2 was a good one. Your first game in Unreal Engine 5 is one that I'm working through right now. I did your first hour in Unreal Engine 5.2 last time. Be a little cautious. There is this dated one, your first hour in Unreal Engine 5.0. So you might like this 5.2 one is just a more recent one. From a experienced Unity developer, I will say don't let yourself get overwhelmed, and don't shoot for the moon. As in, like, you know, oh hey, it's my first day in Unreal and I'm gonna go to hair card generator or whatever, learning agents. Like, no, like something might look cool, like all of these other things that are sub stuff look cool, but don't start there. Take your time and work through pieces. Also, this begin play, if you have the discipline and sort of mentality to just watch, like don't interact, just watch. Do this first. Watch all of these begin play ones. I started there, and even if you aren't going to fully grasp everything that they're going through, it at least is going to start that little seed in your brain to be like, oh, I remember something like that, and it'll be there. It's quite a bit to watch, but they're good overviews. They're really good overviews. So this is where I started. I started with these begin play things. I watched all of these. Highly recommend it. You learn notes and papers when you write it in. Gotcha. I like whiteboards. A little easier than pen and paper to me, but different people have different learning styles. So I'm very much interactive sort. Like I want to see it being done, like a mentorship apprentice type teaching styles. So that'd be right up my alley. Like those old styles of teaching where it's show you how to do it and you follow along. It's like, that's how I learned. Where was I? But yeah, I would definitely start with those, and definitely look around this this tutorial page, especially from the official Epic ones. There's some good stuff. Highly recommend it. I forgot where I was. I need this. I got this camera. I will say that this tutorial that I'm going through right now has a couple issues. At least I have encountered them. But yeah. Let me see. Where are we at now?
So he is slower accelerating and not immediately stopping when no input is there. This may feel a little bit like he's on slippery underground, and we could increase the ground friction a bit, but we will keep this until we have some animations in.
Yeah, okay, we got that.
First, we will create a new folder, naming it animations. Here we will import animations from...
Oh, slow down. Animations. Okay.
From 3 different FBX files.
Okay. Import. Oh, animation. Got it. Okay.
In the import menu, first we will select our skeleton. We will already
okay. Skeleton.
have in the project. We will also not import the mesh, as we also have that. So now it's only the 3 animations we are the mesh, as we also have that. So So now it's only the 3 animations we are getting, and that gives
Okay. What just happened? Is it thinking? What's going on?
us 3 animations. So now it's only the 3 animations we are getting.
Oh, they hit import all, and I only hit import. No importers, yeah. Aha, okay.
And that gives us 3 animation sequences. Let's open the idle, which
Idle. Okay.
opens up this editor. So here on the left are some asset details like play rate, and down here are an asset browser with animations for the skeleton. We have a walk and a run and the idle. Now we need to connect this to our game logic, and we do this by using an animation blueprint for that.
That's cool. That's adorable, Mer, but I only see one otter. Yep, there's only one viable otter shown in that picture. Yes. Oh, I'm so biased. Oh, I'm terrible. Foxes. All foxes. Yeah, I just was looking at that one. Also, like, wouldn't you think that Wolverine would be a Wolverine? I guess that's too easy. Oh dear God. I'm totally getting distracted.
Connect this to our game logic and a run and the idle. Now we need to connect this to our game logic, and we do this by using
I clicked stop.
3 animation sequences. So here on the left are some asset details like play rate, and down here are an asset browser with animations for the skeleton. We have a walk, logic.
Bam, right there. Okay. So we go back to content drawer. We are adding animation and then something.
And we do this by using
animation blueprint. Okay. Animation blueprint.
Using an animation blueprint for that. The animation blueprint is also based on a skeleton, so we pick that from our bot here. And we name it ABP bot. And when we open this up, you can see here's a preview. Below there's graph, functions, and variables from normal blueprint. But the main thing here is the animation graph where we play and blend our.
Did I have lunch? Yeah, I did. Oh, that's why it's getting close to dinner. That's why I'm getting hungry. Oh, okay. So you pulled the cord? What? Where? I don't understand. Got a personal loan so you can keep your score up and kind of. Oh boy. That's a thing, Mer. Hopefully it goes well for you. That is an expensive investment. Best thing I can say, just from my own experience of getting back into things, is you have to not expect to be where you were. Like you don't know to not have God, what's the word? Not unexpected expectation. That's whatever the thing. But yeah, I have learned that those types of skills are what are those types of skills called? They're like not fleeting, but like you have to continue using them or you start to lose them. So it's a lot of getting back into it. Then you get the expensive one, got the 16-inch one. Okay, cool. Hopefully it still works for you. Plus, like, you know, getting into something smaller just to see if it's something that you want. This is a good way to do that instead of going too deep. Okay, yeah, I see. Is this wait, what's the brand name? I can't. XP pen? Is that the brand name? Oh, brand, yeah, XP pen. Interesting. I've never even heard of them. Hopefully it goes well. Hopefully it works well. Pressure on the channel. Another bit of advice, be careful with gravity. Yeah. Something like that's not going to handle getting dropped very well. Or look into a good solid case. I had my Wacom tablet tethered, so it was USB cabled to the PC. In this case, like, say it was plugged into a power outlet or something like that. And I had it on my lap, and I just was shifting position, and like went from cross-legged to not, and yanked the cable as I was doing that without even realizing it, and just literally flung my Wacom off of my lap. It's like, ah, oh, god dang it. I have a lesser version out there recommended this. Okay. Cool. Yeah, hopefully it works out for you. I don't know anything about it. I have never used a screen-based tablet. I just have the tablet. It doesn't actually have a screen. It just references to your other monitor. But yeah. Ooh, tired.
Animations, and there's an event curve for the logic we will use in a second. Let's start extremely simple and just drag in our idle and connect the pose with the output pin. After hitting compile,
connect the pose with the output pin.
We can see the result in this preview. Now let's add this to our BP bot. After opening his app, we can go to the skeletal mesh component. Let's go to the viewport to see what we are doing. And here we change the class to our animation. After opening his app, now after hitting compile, we can see the
Oh, I see. Okay. Wait, how are you?
The pose with the output pin.
Preview out of date. How show compile? Are you actually? I don't see any movement. I don't know. Maybe I did something wrong. Right, you really consider the big ones, but you don't think you have the space in your desk for them? Yeah. Again, gravity sucks. Alright.
After hitting compile, we can see the result in this preview.
Yeah, theirs is wire and graph. BP bot or show. Huh. Alright, well. Oh! I see. Got it. Okay.
Now let's add this to our BP bot.
Why is mine not looping?
Second. Let's start extremely simple and just drag in our idle and connect the pose with the output pin. After hitting compile, we can see the result in this preview. Now let's add this to our BP bot. After opening his app,
BP bot.
we can go to the skeletal mesh component. Let's go to the viewport to see what we are doing. And here we change the class to our animation blueprint. So he's
Yes. Animation. Use animation blueprint, anim class. Okay. Oh! Okay, so it...
playing the idle. Back in the game, he's playing the idle pose while sliding around. Instead, just playing one animation, the animation depends on the state he's in. So he's either standing still or he's moving. We will use
Thanks for the look, mer.
And then we will call that locomotion. So it spits out a pose, and that's something we connect to the machine. And then
oh, just straight up add new state machine. Add new state machine, I guess. It's gotta be what it is.
we will call that locomotion. So
oh,
it
crud.
spits
What did I
out
just
a
do?
pose, and
I was trying to rename it. Locomotion.
and that's something we connect to our output pose here. Let's go inside of the state machine. It has an entry point where it starts, and we can add a state and call this idle. And we can have another state from that idle and call that walk, run. So this is the most simple state machine.
Okay.
We start at the beginning idle, and we can switch to the walk. And the arrow in the middle is a transition. So we also want to go back from walk to idle.
Hold on. What
So
did
let's
you do?
go in idle
Drag
and
that.
call that
Oh, add
walk,
state.
run. So
Got
this
it.
is the most simple state machine. We start at the beginning idle, and we can switch to the walk. And the arrow in the middle is a transition. So we also want to go back from walk to idle. So let's go inside of the idle state. Here we drop in our idle animation and connect that. So it plays the animation when he is in idle state. And when we go back, we can also go into the run and walk. And here for now, just takes a walk. We can extend this later. So now when he's in that state, this is the animation he's playing. So next we need to decide when do we go from idle to walk. And that's where the transition rules comes in. Here we can say you can enter or can't enter the state, but comes in. Here we go from idle to walk, and that's where the transition rules comes in.
Oh, jeez, they don't even say it, like, you double click on that.
Here we can say you can enter or can't enter the state, but for doing that we need some data, which we will get from the event graph. Here's an
Oh my god, event graph, okay.
update node. It's like the tick in Blueprint, and here's also a try get pawn owner node that will give us that pawn. But let's first make a check if this currently has a pawn, so we try a is valid function here. And with this now, we can drag out of the pawn and search for get velocity, which will give us the bot's velocity vector at that given moment, with another vector mass, vector length.
Okay, so exit. What is valid? Utilities vector sequencer. No. Okay, what is this is valid that you did?
But let's first make a check if this currently
question mark is valid. Is valid. Question mark. Ah, there you are. Okay. Is valid.
He has a pawn, so we try a is valid function here. And with this now, we can drag out of the pawn and search for get velocity, which will give us the bot's velocity vector at that given moment. With another vector mass, vector length x and y, we can get a float that represents his ground speed. He's not jumping, so we don't care for the z direction. And this value we save in a variable we call ground speed. So when we connect this now, this gets updated, and we can test this by using our beloved sprint string.
I don't remember how to do this.
Updated.
Set.
And this value we save.
Parameter. Promote to variable. Okay.
In a variable we call ground speed. So
let me change it. I have to change it here. Just out of curiosity, do they actually allow? Oh, that's crazy. So you actually can have spaces in your variables. I'm sure on the back end it's not actually doing that, because
when we connect this now, this gets updated, and
okay, is valid.
We can test this by using our beloved sprint string node. We can plug in the float and a conversion node gets automatically added. So when we now play the game, we can see on the left side its current speed. And it's up to the maximum of 400 we set before. So back in the animation blueprint, we can delete this now. And in the transition rule, we can use this now by getting our variable in.
Oh. Okay. Idle, walk and run. Whoa. Get.
And check if this is bigger than 0. So after doing that and pressing play again.
Oh. Greater.
So after doing that and pressing play again, we can see he is actually going into a walk state, but if we stop walking, he's not going back to his idle. That's because he's going from idle to walk.
Whoa, 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 what was that? What did you just do?
That's because he's going from...
Oh, what did you do? How did you do that? There's a button that he pushed. They made it all nice and pretty. What did you do? What is that hotkey? Oh man, I want that hotkey. I don't know what that was. Bring node alignment. Shift A. Shift D to line. Oh God. No. Okay, that's. Q. Ah, Q. Neat. Okay, remember that one. Holy cow. Okay,
from idle to walk, but the transition back is always set to false. Let's fix that by getting in the ground speed again and check if this is smaller or equal a number. And we can use like something around 5 here. So now back in the game, you can see that when he begins to walk, his animation is played, and when he begins to stop, then he's going back in his idle state.
Okay. Interesting. So, I know what the problem is, but I don't know what it is in Unreal. So, the animations are not looping, but why? Is it loop? There we go. Okay. I don't know if they turn that on and I missed it, or if something. So I don't remember them setting that, but maybe I missed it. All right. Oh, no. Okay. I don't know why. Save all, it's all done. Well, I know that the logic is working because I could start him walking and then stop and it works. It's just the looping is not working. Yeah, I don't know. Okay, so something's wrong there.
And when he begins to stop, then he's going back in his idle state. We can extend this now. Let's go into the walk and run state, because at
Okay, go back to the walk and run state.
a speed of 400, we can extend this now. Let's go into the walk and run.
Walk and run. Walk and run.
State, because at a speed of 400 the walk will not work very well. To improve that, we can use a blend space. It can be found under animations and then blend space 1D, and we base this on our skeleton. We name it BS walk run. And when we name it,
oh, it's a whole new. thing. Got it. Okay. Animation. Blend space.
And then blend space 1D, and we base this on our skeleton. We name it BS walk run. And when we open this up, you can see an axis here below the character, and in the details up here, we can name this axis to speed.
Axis horizontal. Okay.
And we can also set the maximum to 400 to match our character speed we set before. And now we can drop some animations in, like the walk and the run. Deep.
What?
Pending in, like the walk and the run.
Oh, I see. So, speed 0 to 400. Curve?
Depending on the input speed, it will blend between these two. But how do we know that the blending is not feed sliding? Unreal Engine 5 comes with a very cool analyst feature for that. We can choose locomotion as a
Horizontal axis function, locomotion.
axis function, and the analysis needs to know the foot bones.
No way! What? I'd be curious if you can ever get this to work with a quadruped, but oh wow! I mean, arguably, you can just pick two of them. The other two usually on the ground at the same time, but wow! Oh wait, no, because run would be very different in the... Huh. Wonder how you would do a quadruped running with that. Interesting.
So we can look for the bones, which would be foot left. So we put foot left and then foot right. And once we have done that, he knows where the planting is happening.
No way. Like the speed, foot left, foot right. That is ridiculous.
So when we press analyze, he will match the animation.
Press analyze. Where's analyze?
Right. And once we have done that, he knows where the planting is happening. So when...
Oh, I see. Analyze.
When we press analyze, he will match the animations to the right point on the axis. It might have been a little bit subtle because my initial points weren't too bad. But with this blend space now, we can drag this in and use our...
Oh, wait, hold on. That just totally... Okay, I'm confused. I feel like I missed drag and drop animations. So get our walk. We get our run. That's okay, there we go. I don't know what changed.
to the right point on the axis. When we press Analyze, he will match the animations to the right point on the axis. It might have been a little bit subtle because my initial points weren't too bad. But with this blend space now, we can drag this in and use our weren't too bad. The right point. So when we press Analyze, he will match the animation.
How are you? How are you moving?
Planting is happening. And once we have done that, he knows where the plant.
Control separation. Speed 95. 275. I'm very confused.
Thing is happening. So when we press Analyze, he will match the animations to the right point.
So they're dragging this X around, but I'm not able to do that. What did I miss? I don't know what I did wrong. Speed potential 400. I don't know. I don't know what happened. So there's a few things that we haven't been able to actually follow along with.
On the axis. It might have been a little bit subtle because my initial points weren't too bad. But with this blend space now, we can.
Okay, so we go back to our walk run state. Where was that in VP? Walk run state. Then what, we drag that into here? What is this none? I don't know what that is. Scale average. Why do I have that and you don't?
So we put foot left and then foot right. And once we have done that, we can drop some animations in, like the walk.
Access settings. Analysis. It's vertical. Horizontal axis. Tangential. Wait, I wonder. Why do you not have a vertical axis? But I do. Name none. That's where this is coming from. It's gotta be like a setting or something somewhere that I'm missing. Like a different type. see anything relevant on that. So we have an extra axis in here, so I don't understand what's up with that.
And between Unreal Access can look we put done that because and use our ground speed to.
Alright, so either we botched something up or I don't know why I keep saying that. I'm constantly saying we.
Drive back this in and use our ground speed.
Ground speed. Get that. You can see that's going to become a little nuisance.
To drive the axis. So if we now hit play, you can see the character following the mouse and blending from an idle to a walk to a run. So in a very short time, we have our character running around in the world and reacting to our input.
Okay, yeah, it is. That's cool.
Which is pretty cool. So as the bot is ready, we can do even more with it. Let's drag the bot into the scene and control him with an AI controller. Can do even more with it. Let's drag the bot into the scene and control. So as the bot is ready, we can do even more with it. Let's drag
Where are you? Oh, because it's okay. I see. It's counting when I try to focus, it's counting on the camera as well. This is something that I'm not super keen on, and I wish. Yeah, I don't know. Okay, whatever.
the bot into the scene and control him with an AI controller. Because of our setup, having the player controller controlling the bot, we can also have an AI controller as a brain for the body. So back in the blueprint window, we can search for AI and select the AI controller name body. So back in the blueprint window, we can search for AI and
Sure, AI control. Okay. Blueprint. AI controller. Okay.
select the AI controller and name it BP_AI controller. When we open this up and go to the event graph, we will not add movement or use a tick, so let's delete that. There is an AI move to function in the AI controller we can use to give him some orders. So now, how and why and when do we give that order? So let's do something simple first and execute this function a few seconds after the game starts. We use a set timer, but how and why and when do we give that order?
Jesus Christ.
So let's do something simple first and execute this function a few seconds after the game starts. We use a set timer by event function and we set this to like 3 seconds. Now we drag this delegate out and type custom event. And this event we call simply move. So now we connect the AI move to function, and the last thing we need is give this order to the pawn which we currently controlling. So back in our map, we select him, and in his thing we need is give this order to the pawn, which we currently
Control pawn.
be controlling.
Ooh, okay. That's not so pretty. Okay.
So back in our map, we select him, and in his details we find the AI controller class, which we set to our newly made BP AI controller.
AI controller class. Pawn. I know I can search for it. I just want to see for myself how this works. I feel like there is so much overhead with all of this stuff here already loaded, but from my understanding, Unreal is supposed to be pretty solid. Oh yeah, there it is. So I'm guessing it's got some pretty good, just don't include things that it doesn't need. Yeah, AI controller class. This gets set to our, yep, there it is, BP controller, okay.
The last thing he needs is to move around. We set to select him, and in his details we find the AI controller class, which we set to our newly made BP AI controller. The last thing he needs is to move around is navigation data, where blocking is, etc. So we go to the create menu, type nav mesh, and select the nav mesh bounce volume.
Oh boy, wow. Alright. Nav mesh bounce volume.
When you press P, you can make the nav mesh data visible and invisible.
Oh, really? Which I'm gonna guess. Oh man, I'm still not used to hotkeys. I have no idea what that is.
Press P, you can make the nav mesh data visible and invisible. Let's now cover the whole area. We want our little robot to be able to walk in, and then scale this up a bit. This should work for now. So when we press play, we can walk around. This should work for now. Able to walk in, and then scale this up a bit. This should work for the robot to be able to walk in, and then scale this up a bit.
Okay, it's not going to let me do that. What is this pressing P? I think is what he said. Oh, wait. Oh, it is. Okay, there we go. I have a feeling that I'm very much doing this wrong. Nav mesh volume instance.
We want our little robot to be able to walk in and then scale this up a bit. This should work for now. Able to walk in and then scale this up a bit.
Yeah, this is actually finding, like I can see it's finding pathing stuff, but I'm not able to get whatever it is they've got going on there. Press P. Oh, navigation. Oh, okay. So it's not a matter of having that selected or not. It's just... Okay, what does this say? Recast image static. Agent. Nav data count. Using cluster links. What did I do wrong? I gotta be doing something wrong. Alright, well, I don't think that the nav mesh is working properly, but I don't know why.
This should work for now. So when we press play, we can walk around and you can see him begin to run after around 3 seconds, but he's trying to reach 0, 0, 0 because...
Okay. What is your current location? You're not 0. Good. Do you actually do anything? Oh, where's the other bot? There he is. Yeah, he's not doing anything. He doesn't have a path. It's the nav mesh isn't working, so I don't think he can actually utilize it. I don't know what's wrong with the nav mesh though. Nav mesh volume. I need timestamps on this. Okay. Something is very clearly wrong, but I don't know what.
Because that's what the destination is by default, and we will keep it like that and come to this later. All bots have the same color, and to avoid an identity crisis on our bots, let's change that. We will use the construction script of our bot for that. When we...
Oh, getting frustrated. Like, at some point, there's only so much deviation you can make away from a tutorial, and it's just like, okay, what did I do wrong? What's missing? Did I do something wrong? Is there a version difference from the tutorial to what I'm currently running? I don't know.
And we will keep it. Makes enough where blocking is, etc. So we go to the create menu, type nav mesh, and select the nav.
So we have nav mesh bound volume. Oh, there you go. Okay. Now we're getting somewhere. Oh, I see. Okay. Aha. Oh, oh, there he goes. Haha! Neat. Interesting. That's actually facing the right direction. Very curious. Very curious indeed.
Mesh bounce volume. When we press, but he's, and we will keep crisis on our bots. Let's change that. We will use the constructions that have the same color, and to avoid an identity crisis on our bots, let's change that.
Okay.
We will use the construction script of our bot.
Construction script, okay.
For that. When we select our mesh, we will remember that our bot has two materials.
Select our mesh, okay.
And his body material is element 0. This material has a parameter I already renamed to color.
Body mesh. Parameter. Okay.
Back in the construction script, we can grab
bot
the mesh and drag
the mesh. Okay.
it into our graph. And from there, we add a node called create dynamic material instance. And we do this on the element 0, which is our body material. So here we can use the instance and now set a vector parameter with our color.
Parameter 0, return value, set vector parameter value, colors badger and fluorescent green and yellow.
So the parameter name we change to color and change the color to blue.
Color,
After hit compile, we can see
value.
him in blue in our scene. But now
Sounds
all bots
great.
in the scene would be blue. To change it per bot, we can drag the color out of here and promote it to a variable. And we name that color. And with
variable.
this little eye icon here, we can expose this variable to be editable per instance. You can see this also
Color.
up here. And then we change it back to our this little eye icon here, and we can drag the color out of here and promote it to a variable. And we name that color. And with this little eye icon here, we
Icon, okay.
can expose this variable to be editable per instance. You can see this also up here.
Instance editable.
And then we change it back to our orange.
Value. How do I change the value? How did you do that?
You can see this also up here.
Oh, compile. Got it, okay. Bot base. Cancel. Go here. Color. Put this in. Okay.
And then we change it back to editable per instance. You can see this also up here. And then we change it back to our orange we had before. Now we can give this little bot his own individual
Oh, yeah, it's right there.
color by going here in his details panel and picking something like, I don't know, something like a blue. I will settle on that for now. So we have our own controller and an AI. So let's do some more game logic. First, let's bring in some more props. So we go to our props folder, import, and then we import a wall, a door, so an AI for now. Picking something like, I don't know, something like
Why is it not changing your color?
I will settle on that for now. So we have our own controller and an AI. So let's do some
color. No. File. Parameter name, color. What did I miss?
editable per instance. You can see this also up here. And then we change it back to our orange we had before. Now we can give this little bot his own individual color by going here in his details panel and picking something like, I don't know, something like a blue. I will settle on that for now.
But it's not working.
So we have our own controller and an AI. So let's do some more game logic. First, let's bring in some more props. So we go to our props folder, import, and then we import a wall, a door, an orb, and some meshes for a pressure plate. When all it's controller and an AI.
Why is your color not changing? I don't understand. I don't understand why you're not working. Oh, wait, no. Did I? Let's say material parameter. Today.
So let's do his own is to change in blue to data with 0 with node constant 0. Our mesh on our bots, let's change that. We will use the construction script of our bot for that. When we select our mesh, we will remember that our bot has two materials and his body material is element 0. This material has a parameter.
Yeah, param color.
I already renamed to color. Back in
channel names. But I don't. I don't know what's with those, yeah. Ready description. Primitive index. What am I missing?
In the construction script, we can grab the mesh and drag it into our graph. And from there, we add a node called create dynamic material instance. And we do this on the element 0, which is our body material. So here we can use the instance and now set a vector parameter with
there it is.
color.
Maybe I didn't have the thing compiled. Alright, cool. Now it's working. It must have been a compile issue. God, that really is... I'm used to Unity that's just like auto-compiles all the freaking time. Like you really gotta save and compile and remember to do everything.
So the parameter we add something like, I don't know, something like a blue. I will settle on that for now. So we have our own controller and an AI. So let's do some more game logic. First, let's bring in some more props. So we go to our props folder, import, and then we import a wall, a door, an orb, and some meshes for a pressure plate. When we a door, an orb, and some meshes for pressure.
Door, wall door, orb, frame, pressure plate.
When we import them, they conveniently use the same materials we already created. So that's nice. We will first start with our orb here.
Orb. Is that SM pickup? Is that what you did? SM pickup.
In game elements, we will create a new blueprint based on a simple actor
So, what did we say? Game elements. Blueprint based on.
and call. We will create a new blueprint based on a simple actor.
Simple actor.
And call that BP orb. When we open this up, we can use the content drawer to drag and drop our meshes into the scene, which is automatically creating static mesh components. We can use the content drawer to drag and drop our meshes into the scene, which is automatically creating static mesh components. We can make this a root element, and then on the details panel, we can go to the collision and make this a root element.
What? Make this root element?
What? The scene, which is automatically creating
static
mesh
just drag it.
We can make this a root.
Got it. Make it the new root. Root was deleted. Okay.
Root element, and then on the details panel, we can go to the collision and set this to overlap with pawns.
Overlap only pawns. Physics. No. Collision. Collision preset. Overlap only pawn.
Only. We will use this later. But first, let's see how we can spawn that into the world. So we go back to our player controller and we want to trigger an action depending on an input. And we want to trigger, we go back to our player controller and we want to trigger an
player controller. BP player controller.
An action depending on an input. So once again, we go to the project settings and there to input, and we add another action mapping.
Okay, this is different.
This one spawn orb.
So we're gonna do this a little differently
and
than
we
what they
press
say.
here and hit spacebar to bind that
So we want
to that
spacebar. Can I do spacebar? Keyboard event spacebar. I don't know if this is the new input system, but it's what I'm going to use for now.
But action. Back in the controller, we search for spawn orb input event, and then on the release, we use a function called spawn actor from class, and the class we want to pick is a BP orb. So with a right click and
BP orb. BP orb. Can I focus? No.
split, we can
spawn transfer. Wait, what?
So with a right click and split, we can
Right click, split. Oh, location, rotation, scale. Got it. Okay.
access the variables of the struct. So
Can you undo that? Recombine. Okay, that's cool.
we need a location to spawn it. We can use the same location where the bot is in the moment
Connect to location.
we hit the space bar. So we add this to the location, hit save, and now we can walk around and spawn orbs. With orbs in the world,
Okay, that's enough of that.
we want the AI now to collect them. So instead of walking to 0, 0, 0, we want the bot to go to an orb. And we can use an function to find an orb. And we could
Where
go
did you
to
go? Okay, PPAI controller. Okay.
instead of walking to 0, 0, 0, we want the bot to go to an orb. And we can use an function to find an orb. And we call this function
Okay, okay. What do they do? They hit plus? Oh, yeah, okay.
find orb. This function should output if it found an orb, so we do a boolean which we call success, and we
What?
add a second one and change the type to an actor, which we will name orb actor. So let's make the logic for that. First, we want to get all actors of class.
Actor.
And here we want to look for our
Dude,
BP
okay. No, go
orb.
back. I gotta figure out what the heck did you just do?
And change the type to an actor.
Object types. Got it. Okay.
Which we will name orb actor. So let's make the logic for that.
Your lack of consistency with casing is bothering me.
First, we want to get
Okay.
all actors of class. And here we want to look for our BP orbs.
Class. This feels very inefficient. But first, get it to class. Maybe orb.
In the scene. This gives us an area of all orbs. It's basically a list. We can use getLength of that list to check if something is in it. So if this area is bigger than 0, we can use a branch, and if this is
Length greater than 0. Branch.
true,
Condition.
we found something. And if it's false, we say we were not
Okay. Success false. Success true.
successful. And if it's true, we found orbs. So now we make this simple and just get the first orb in that list and plug that into our return node. And when we hit compile and go back to our event graph into our return, just get the first orb in that list.
What the heck did you just do?
So now we make this simple and just get the first orb in that list.
Get a copy.
And plug that into.
Oh, I see.
Our return node. And when we hit
That's
compile
really ugly,
and go back to our event graph, we can track in our function.
Compile. Wait, how do you go back?
Hit compile and go back to our event graph.
Oh, event graph. Oh, I see. Okay. Dragon, find orb.
Graph, we can track in our function. So we made our own node. We could now hook up like we did before, but in this case we can make this function pure, and when we drag this in now, it doesn't.
The heck, it's pure.
Have execution pins. Be aware that also means each time a value is needed from this node, it will be executed, but that's okay for here. So if we are successful, we will do the AI move to command, and we will use.
Okay. Branch. Whoa. Interesting. Condition. Okay.
The orb actor output and plug that into the target actor. And then when the AI reaches the destination successfully, we want to move again. In addition, we want to change our timer and successfully into the target actor. And then when the AI reaches the destination successfully, we want to move again.
Move. Success. Move. Move. Call function move. Oh, move. Move. Oh.
In addition, we want to change our timer and check that this is looping, so it's checking every 3 seconds. When playing now, we can spawn orbs, and our little blue robot will go and run to the orb. But as the orb still will be the first in the list, he will not move to another.
Yeah, that makes sense. Alright, cool.
That we need to remove it from the world. To do that, we can use events the components can give us. For example, the begin overlap event. We already know this actor will own can give us.
BP orb magia. BP orb. Where is it? BP orb, there it is. Okay. Add event on component end.
For example, the begin overlap.
Begin overlap. Begin overlap. It's effectively on enter in Unity.
Event. We already know this actor will only overlap with pawns because that's what we said in the details. That includes our own bot and the AI bot. Here we get the actor that begin to overlap with this orb. We don't want our player to directly remove it after it got spawned, so we have to differentiate between them. So we cast to a pawn. Carefully with casting, it has hard references, and it means when an actor gets loaded in memory, everything it's casted to will also be loaded. Now we drag out the pawn and we can ask if this is player controlled. As we have an AI and a player controller, this will give us a desired result. So if the bot is not player controlled, we will destroy and thus remove it from the world. Here we are. So now
false.
Now let's hit play and see what it. Does. We can spawn orbs and the AI now begins to follow us and collecting those orbs. So here we have it. Running around, spawning orbs and having a little AI following us. Now let's add some more interaction and do some more game elements. We will do a pressure plate that will open a door and we want our robot to be able to trigger it. First we create another blueprint for more interaction and do some more game.
Holy cow. Oh boy.
Game elements. We will do a pressure plate that will open a door and we want our robot to be able to trigger it. First we create another blueprint door and we want our robot to be able to trigger it. First we create another.
Okay. Game elements, new blueprint, actor.
A blueprint actor and name this one BP pressure plate. And when this is done and we open it up, we can drop in our frame and platform mesh.
Frame and platform mesh. Oh,
and then
two
make
of them. Okay.
the frame our root.
Why is yours white?
In our frame and platform mesh.
Platform into. Don't care enough.
And then make the frame our root.
Frame becomes root.
What we want
Okay.
to do is move the platform up and down when something stands on it. To do that, we will add a box collision component that will serve us as our trigger.
Box collision.
To do that, we will add a box collision component that will serve us as our trigger.
Collision.
So let's
Okay.
scale this up a bit so it covers the area we want. And now we want to add a begin overlap event like we did before with the
Okay.
orb, but this time we also want the end overlap event. And we now
Box event. Oh, it knocks them out when they. Okay.
want to test if this is working. So we use our print string again.
That's fine.
And keep the hello for the begin overlap by the content raw. So we
I got AFK a minute.
With this done, let's go and bring in the pressure and by being triggered when we begin and end overlap. So this is already working quite nicely. But we don't want to output some text, but move the platform mesh up and down. So back in our pressure plate, we will first remove this print string nodes. And to do the animation of the pressure plate, we will use a timeline. And we name this plate animation. So when we double click, we can add different tracks to this one. But first we want to go pretty fast, so we set the length of this timeline to be ½ a second. And next we will add a float track. So this track we will use to animate the plate movement. Now we can add some keys. So the first key is at 0 second and the value to be 0. And then we do another key, and that one will be set to 1 after ½ a second. And with these buttons, we can focus on that area. So this value will increase over time from 0 to 1, and we will use this to move our plate. So here, over time from 0 to 1, and we will use this to move our plate. So here is our float pin that will give us a value when the timeline is playing. We will take the platform mesh in here and look for set relative.
Why don't you just do SM platform? Okay.
Location. By start, this is 0, 0, 0. We want to have this updated when the timeline plays. As we only want to change the Z value of this vector, we will use one of the mask nodes and search for multiply. The pins here are grayed out because it's wildcard pins that can become different variables. They get here are grayed out mask nodes and search for multiply. The pins here are grayed out because it's wildcard pins that can become different variables. They get automatically changed when I track something in. And now we can split our location vector and connect the output to the Z component. So when the platform reaches 1, we want the plate to be at around -20. So let's hook this up in the timeline, and we can do it play and reverse when end overlay with plate. So now back timeline, and we can do it play.
Reverse, Jesus Christ. Just straight up, that easy. Oh my god. This is absolutely insane. There, that pin.
And reverse.
Okay. Ah, look at that. That's insane.
When end overlay with plate.
Oh my god.
So now back in our level, we can run around, and you can see it's already triggered, but maybe a little bit hefty. So before we continue, let's stop here, go back and fix this. The value is a little bit high, so we go to -10, and I think that should work better. So let's play again and see how that is doing. Yeah, that's what we want. So the plate is moving down and up. So we have the pressure plate. Now let's create another actor for our door and call this one BP door.
Actor. BP door.
When we open this up, we do the same as before. We will go to our props folder, and first we will bring in the wall frame and make this one the root.
Okay, wall frame. Wall, wait. Oh, okay, got it.
Next, we need the two door meshes. It's the same mesh for both, so we will add 2 of them. And let's name one door L for left and the other one door right. As we want them to move around here, but it would be easier if the relative location would stay at 0,
Oh, I
0,
see.
0.
They're
So
doing...
let's do a small trick. We will add a scene component, and we call this small trick. We will add
the scene component. Scene component.
add a scene component, and we call this like anchor underscore L. And we move that to the proper position. Then put the door.
How do I know which way is forward? That, okay.
Under that anchor and bring back the relative location to 0.
Okay, that goes there. 0 for that. That looks good to me. Rinse and
We
repeat,
do
I
the
assume?
same for the other side. So we add another scene component and call this one anchor underscore R. And then move this to its proper position on the other side. In this case, the door moves in the opposite direction as the other, so we rotate this one 180 degrees. And now we can put our door on the other, so we rotate this one.
Neat.
180 degrees. And now we can put our door under the anchor, and we have a setup we can easily work with. Back in our event graph, let's first delete those nodes.
Okay.
Because this time we will start with custom events. The first one we want to do is calling this one open door, and then we need a second one we will call closed door. And again, we will do a timeline calling this door animation. This is nearly the same setup as before. We will do one tiny thing different, which you will see in a second. So door animation, and then this time we will make this also as short 0.5 seconds. We could also do vector tracks here, but I personally prefer to work here in a 0 to 1 space and tweak the values afterwards with a multiplayer without the need of changing the curve every time. So the curve we want to model just like how in this case the animation is played. But first we need this first 2 keys, and then we can do it a little bit more interesting by selecting those keys and changing them from linear to break. And that gives us tangents, and this tangents here we can use to manipulate the curve. So we can bring this down to have a more interesting slide. We can from linear to break, and that's a little bit more interesting by selecting those keys and changing them from linear. To break, and that gives us tangents, and this tangents here we can use to manipulate the curve. So we can bring this down to have a more interesting sliding. And back in the graph we can take both door components and again look for set. In the graph, we can have a more interesting sliding. And back in the graph, we can take both door components and again look for set relative transform. We put this under the anchor, so that will help us a lot. Again, we split the
Oh, I'll need one of these. Wait, what?
vector under the anchor, so that will help us a lot. Again, transform can take both door components and again look for set relative transform. We put this under the anchor, so that and again look for set relative transform. We put this under the anchor, so that will help us a lot.
What? What? How'd you do that?
Relative transform. We put this under the anchor, so that will help.
Wait, set relative location. Aha! Okay, got it. Okay, that's fine. Oh, bugger off. Ooh, that's ugly. Sure.
Will help us a lot. Again, we split the vector, and this time we use a multiply again, and we will
Update goes here.
multiply it with -70. We connect it to the Y component, so the door slides in and out of the frame. So open door should play time forward and close should play it in reverse. So this is it, and for a quick test we want to see if this works, so we will get back our begin play. We want to open the door after a few seconds. I normally prefer the set time setup, but we will use a delay node, which will work for now. And then we will open the door. So we can go back to our level, look at our BP door, we will open the door. Node.
Event begin play. Delay. 3 seconds.
Which will work for now.
Open door.
And then we will open the door. So we can go back to our level, look at our BP door, and drag that into our level. Let's
Something's very wrong. There's only one door there.
try to find a nice spot, like here.
Why is there only one door there? Huh. Curious and curiouser.
here at the entry or exit of the valley, so we have to try to open that. We could properly place it a little bit nicer, but I think this works for now. So et voila, after 3 seconds, the door will swing open. So how does the plate, after 3 seconds, the door will swing open. We could properly place it a little bit nicer, but I think this works for now. So et voila, after 3 seconds, the door will swing open.
But it doesn't. And... oh, now it's there. Weird. Okay. Oh! Oh! Okay, it did open.
So how does the plate now tell the door when to open? There's a lot of ways to do it, and you can look into Blueprint communication to learn more. I want to show you one way, and that is using a known component. We can create a plate now tell the door will swing open. So how does the plate now tell the door when to open? There's a lot of ways to do it, and you can look into Blueprint communication to learn more. I want to show you one way, and that is using a known component. We can create a blueprint here, and we find an actor component.
Where are you, framework? Blueprint actor component.
Let's create one, and let's call this one BP interaction component. Imagine this to be a small container for game logic you can add to any actor in your project. So when we open this up, it looks like any actor blueprint we have seen before, but it doesn't have a viewport or components. Let's remove this for a second. We will do something extremely simple here. We create a custom event that we can call from. We will do something.
Well, let me delete those, but okay.
Extremely simple here. We create a custom event that we can call from.
Wait. Can I create as a read-only? Why is it read-only? Oh, I'm in. Got it. Okay.
We will do something extremely simple here. We create a custom event that we can call from outside later. First, we call start interaction, and then we do a second one, and this one we will call stop interaction. Next, we will use an event dispatcher, which will give us a possibility to shout out into the world that this event occurred, and we call this one on interaction. And up right here, we can add a variable, and we keep it a bool and and up right here that this event which will and we keep it a bool and say simply on. Now we can drag it in and call this, and we keep it a bool and say simply on. Up right here we can
Oh, I see.
Add a variable, and we keep it a bool and say simply on. Now we can drag it in and call this one from start interaction and say this is on, and then we do a second one on stop interaction, and here we say it's false. That's all our component will need. So let's hook this up. In the pressure plate, we can now add our new component we just made. There it is. So let's move the overlap events a little bit to the side. And then we can drag in our component and use it as any other. From here, we can call the events we created. Start interact, on begin interact, and then start the animation. And also stop interaction when the end overlap is called, and then play the animation in reverse. To show this is already working, we go back and use our print in reverse when the end overlap is called, and then play the animation in reverse. To show this is already working, we go back and use our print string again and move our character around. So when we enter the blade, you see on and off. So this is already working quite nicely. Now the door needs to react on that. Back in our door, we can remove our test code for opening the door. Now the door needs to react. We want to listen to the event dispatcher of the component that's the door. And
right. I'll figure out why mine is not behaving quite right. Sneaks in, opens the door, closes the door against Badger's order, just to help try fetch it. Thanks, Mer. Okay. So, now I see why that was being a problem. So... that's what I do. That's the anchor there. So what, I want this to be rotated 180? Got it, okay. Aha! Less aha. Okay. So you're not resetting when I leave. Oh, wait. Is that thing sitting on there? No, I don't think so. Let's find out though, because all I need to do is just not move. Okay. It is. Okay. How do I make it so that you don't actually exist? I don't want you just... So I didn't start up. No. Curious. So Unity has a thing that you can just like disable something. So it's like, I don't want this to exist. It won't start, it won't run, it doesn't do anything, but it's still there in the editor. But it's not there when you actually try to play it. Regardless, I can just move this. Okay, let's see. Is it the box that's the problem, or is it just... It's interacting with something else.
At begin play, we want to listen to the event dispatcher of the comp. Now the door needs to react on that. Back in our door, we can go around. So when we enter the plate, you see on and off. So this is already working quite nicely.
Is it going off? Do they close? I want to see your door close.
This is already working quite nicely.
This
now the door needs to react on that. Back in our door, we can remove our test code for opening the door. And at begin play, we want to listen to the event dispatcher of the component opening the door. The door needs to react on that. Back in our door, we can remove our test code for opening the door. And at begin play, we want to listen to the event dispatcher of the component that's calling out into the world that an interaction started or stopped. First, we will add a new variable type and call that trigger. Then we change the type from a Boolean to an actor object reference, because any actor could actually have our interaction component. We can drag this variable in, and then we can check if this is even existing. So we do a right click and change this to a valid, and then we can check if we have our interaction component. We can drag this variable in, and then we can check if this is even existing. So we do a right click and change this to a validate get. And so we do a right click and change this to a validate.
Click for it to validate. Oh, that's cool.
Validate get. And now from that trigger, we can move this pin out and search for get component by class on that actor. So here we can check if this actor has a BP interaction component. So again, we check if this is valid. And when both is the case, we know we have an actor here that has our game logic we just created. We can track out here and assign a custom our game logic we just created. And when both is the case, we know we have an actor here.
Okay.
That has our game logic we just created. We can track out here and assign a custom event to this event dispatcher we called onInteract. So at begin play, we assign this event to the event we called
bind event onInteract.
Track out here and assign
on what? Oh yeah, it's got this whole like combo thing going on here. Okay.
A custom event to this event dispatcher we called onInteract. So at begin play, we assign this event to the event dispatcher, and when this is calling out, we can react on that. We can now use a branch again to decide what to do when this is true or false. So if it's true, we want to open the door, and when it's false, we want to close the door. And with this, we are done. So let's save and go back into our level and set the trigger variable by selecting the door. And I forgot something. So we have to go back to the door and make the trigger editable per instance with this eye icon. So let's compile and go back. And when we select the door now, we can use a picker to select the pressure plate. When we now start
the door.
with this eye icon. So let's compile and go back, and when we select
the door, default trigger, there it is.
The door now.
BP pressure plate, okay.
We can use a picker to select the pressure plate. When we now start the game, we can walk onto the plate, and that triggers the door, and it leaves the door.
Does it actually work for that then? No.
Door and open and close. And it also means when we now spawn our orbs and our little bot collecting them, we can make him open the door for us so we can safely leave the valley. Woo! Even after so many years, I still love the moment when all these little features come together. Oh, by the way, we also can push the crate onto the pressure plate because we didn't check who's overlapping with it. Let's do a bonus round and add a bit of polish by adding effects, sounds, and a bit of camera shake. So many open the door.
Okay,
and
so
we can
why is my door
So let's compile and go back
not
per instance.
actually working? Gameplay. Get is valid. Target. BP interaction. Churn. Input. Oh. Hello. I'm missing a thing here. Is valid goes to this. Okay. That goes there. Is that all I needed? Ah. Ha! Huzzah! Sweet. I can't actually go through the door. That's fine. Okay. Doesn't look the same as the example, and I have it. Yay, yes.
With the game, we can walk onto the close. Collecting them, we can make
Tails!
them
All
open the
tails.
door. I love the moment when all these little features come together. Oh, by the way, we also can push the crate around and add a bit of polish by adding effects, sounds, and a bit of camera shake. We will start with a dust effect for the bot's running animation, and first let's make a folder and call that effects.
Effects.
Here we create a completely empty Niagara system, and we will call this one FX dust. So let's open the Niagara editor. Again, we have in the middle a big graph. Here are some parameters and here is a preview. We will do something extremely simple. First, we want the system not to loop, but only play one.
The heck? Where did you do it? Loop. No? Oh, once. There we go.
Once. Next, we need an emitter. We could use one of the many templates, but we'll start an empty one. This also has life cycles like an actor, but in update, we add a burst, a spawn burst. And let's add something like 10
Empty.
particles. In particle spawn, we can set some update, we add, but we'll start an empty one. This also has life cycles like an actor, but in update, we add a burst, a spawn burst. And let's add something like 10 particles. A spawn burst. We need an emitter. We could use one of the many templates, but we'll start an empty one. This also has life cycles like an actor, but in update we add a
Emitter update.
burst, a spawn burst.
Spawn burst instantaneous. Update. Spawn burst instantaneous. Okay.
And let's add something like 10 particles. In particle spawn, we can set some particle values. First, we set the color to do something that could look like sand. Next, we want a bit of randomization for the size of the particle. So let's check uniform, random uniform, and do something between 2 and 4. We also want to randomize the mass a bit for the gravity we will introduce in a second. And next, we want to add some velocity when the
What? Mass. Oh, random.
particle gets spawned. Next, we want to add some velocity when the particle gets spawned. Adding this also needs a solve for when the second. And next, add that of a linear force of solve t when the particle gets spawned. Adding this also needs
velocity. At velocity
needs a solve forces module, which will be added when we hit fix.
Fix issue. God, this guy goes really fast.
Instead of a linear force of all particles, we want to
cone.
Switch to cone, and the direction of the cone we want to set to -1 to fit our
-1
character later. So in preview, you can see now 10 yellow particles moving in -x.
Next, we want to add some velocity. The badger gets respawned, turn up treadmill to max. Oh, Jesus Christ.
We could change the velocity speed, but we'll keep it for now. There are many more things we can do with our particles, but we will keep it simple. As this should be dust, we want to scale it up over time. So in particle update, we will look for something called scale sprite size. This gives us a curve, and we want it to be much bigger, like maybe something like 15 when it's the end of his lifetime. So you can see now they are getting much bigger. Now they should move a little bit more interesting. So we can add a curl noise to get a little bit of chaos. A little bit more interesting. So we can add a curl noise to get a little bit of chaos. We can increase the strength a bit, which gives us this. So next, we could also change the frequency, but we will keep it for now. Next, let's add some gravity. So if we add gravity as a force, they will by default fall down with -980. We do not even want a negative value. So like this, in our case, we want to get it a positive value. So that's much better. Maybe this is a little bit much. So like that. Here is where also the masks come in that we set earlier. Last thing is changing the alpha over time. So it come in that we set earlier. Last thing is changing the alpha where also the mask, maybe this is a little bit much, so like that. Here is where also the mask come in that we set earlier. Last thing is changing the alpha
scale color
over time, so it blends out. We can use the scale color, and we can change this from a fixed number to a float from curve. Now we can track the 0 value to happen a little bit earlier in the time, and we have particles that begin to blend out. Niagara is very powerful.
0.6 100%. Perfect.
And I'm using only a super tiny piece here, but we need to move on and see how we can use a dust now. To spawn that on the food steps, we will go to our animation and open the run animation.
Run.
Animation. Let's change the camera angle and stop here. Below of the camera we have different tracks and one of them is called Notify. We can scrub to where the right food is touching the ground where it's planted, like here for example. Right click and add Notify is where we find Play Niagara Particle Effect. When we select this, we can add our dust effect in the details. And when we now moving on the timeline, we can see it gets spawned and played once, but it's spawned at 000 of the character and not where the food is. We can add a bone or a socket name here and we will pick food R for this right food. Now it gets spawned. Where the food bones are. Let's do it for the other leg as well. We will add a Notify. First we will scrap where it is, so here, and then we will do right click and add a Notify. Select the event and we switch this to food left. Now we have them spawning at the right location at the right time. When we now go back in our level and hit play, we can see the particles getting spawned.
Still don't have the rotation part working. I have no idea why that's not working. Ah, look at that. It's a little much, but sure.
When he's running around. So we are leaving a little trail of dust behind us. Audio can help greatly with player feedback and is as important to a game as all other aspects. Let's make some procedural generated footsteps. We will add a new folder and call this audio. For this one we will use Meta Sounds, which is a plugin you might have to enable under plugins and restart your engine. Use Meta Sounds, which is a plugin you might have to enable under plugin.
Oh, Meta Sounds is already in. Cool.
And restart your engine, which I already did here. So we will add a new Meta Sound source asset, which we will find under source and call this one SFX footstep. When we open this one, a new Meta Sound source asset, which we will find under source and call this one SFX footstep. When we open this up, you will see a big graph again. We can compare this with a material editor where you will see X footstep. When we open this up, you will
as you open it. There we go.
See a big graph again. We can compare this with a material editor where you can play pre-made sounds, music, mix it, or even generate sounds out of thin air. Which I do here with a white noise. Wow, that was loud. Let's control this noise by adding an envelope. There are several ones. Wow, that was loud. Let's control this noise by adding an envelope. There are several ones, but we want the one that outputs audio. We multiply this result now with our noise audio. We multiply
envelope. Audio. Sound trigger.
Multiply this result now with our noise. And then we connect this to the output. We also connect the on done pin to the on finished, so the sound knows when it's ended. Let's hear how that sounds like.
Wait, okay. Output unfinished. Oh shit. Oh, I see. Undone, unfinished. Output goes there. You do. Okay.
Knows when it's ended. Let's hear how that sounds like.
Nothing? Curious. Why? Do I not hear anything? Even when it was linked, like this should be correct, but it still wasn't doing it, so I went to link it directly to the thing, which is what they did when I said, oh, that's loud. I was like, what am I doing wrong? What's 0.1 111 looping done. Okay, I do see a little.
When it's ended. Let's hear how that sounds like.
So they have a
We can hear
decibel
difference as this sound is now bleeding
level.
in and out. Let's modify.
They have a decibel level thing here. So when theirs plays, it pushes a decibel level up. Mine doesn't even do the decibel level. So I was curious if like my audio settings were wrong or if I did something wrong here. So it's something is wrong here. But what? Oh. No? Why is it? Meta sound contains warnings and playback behavior may be entered. Okay, what's your warning? What? Where? What's the warning? Oh, warning. Unfinished should be connected to for one-shot sound sources for sources of underlying duration to remove one-shot interface from general. Weird. I don't know what's wrong. Just as pure curiosity, let's double check something. We're running in 5.2. Let's do this. Have you checked your audio settings for the program? As best as I could. Okay. So, Unreal in general does allow to have audio. This is a different thing. Like, this is a whole different scene thing. A whole different project. Sorry, that's what I was going to. So, it's not that. So, Unreal can play sounds on my PC. It's like, start at base, ground zero, proof of concept. So,
Or even generate sound material. Open this up, which I do here with a white
noise, audio,
noise. Wow, that was loud. Let's control this noise by adding an envelope. There are several ones, but we want the one that outputs audio. We multiply this result now with our noise.
I have no idea.
And then we connect this to the...
Oh, dude, I just remembered. This has nothing to do with the audio, but I just remembered a thing. This is with the rotation thing a while ago. I read this earlier and I totally forgot when I finally got there. Where was it? Where's this? The BP bot version in the details panel room. Search for use controller rotation. Yeah, false. What was it? BP bot. Print. Root component. No. Where was it? The BP blat blueprint, and in the details panel, the root component. Search for. Oh, wait. This is root. Yeah, no. details, rotate. Control rotation. Yeah. BB bot. Rotate. Oh, for one, I need to be out of that. That. Okay, there's the rotation issue fixed. So that was one of the big problems that I had. I completely forgot that they had called that out in the description of the thing. Okay. So we still have issues with audio. I don't know what's up with that. I don't know. I'm gonna
output. We also
move
connect
on.
the on-done pin to the on-finished, so the sound the curves. We can extend this now by adding a square generator. Here we set the frequency very low, and now add this to our noise with an add node. And then we will plug this in to the multiply with our envelope, and that's what we got. This in to the multiply with our envelope.
This. Not that it's gonna work for me, but frequency 10. Modulation 205. Poly smooth. C minus 0. Okay. Oh, jeez! Suddenly it's working. Doesn't make any sense. Yeah, just in general, it's suddenly working. Like, not even adding the square thing mattered, because I just removed it. It's suddenly working now. That is very loud, though.
And that's what we got.
So, an interesting point. This is probably the third or fourth time now that I have, like, saved and compiled and done everything that I think I can, and something's just not working. And then I go back, and I don't feel like I changed anything, and suddenly it is working. It's like there's some really fiddly stuff.
Apply with our envelope, and that's what we got. So we increase the pulse width a little bit, and the noise is very loud. So we multiply this with a float, like something 0.1, and then plug that in. And this is the result. I'm obviously not a sound expert, but I hope you can get an idea how powerful this is. So it's close enough for me. Back in our run animation, we can add a new notify track. So let's stop this for a second.
Oh, how did you do that?
You can get and then plug that in. And this is the result. And the noise is very loud. So we multiply this with a float. Like.
How did you do that? What? Multiply audio by float. Got it. Okay. Like 1.
like something 0.1 and then plug that in. And this is the result. I'm obviously not,
Right.
and
Your steps are much faster than mine, so what did I do different? Frequency, see, attack time, 0.01, no. Decay time, 0.3, 0.1, 0.2. There we go.
this is the result. I'm obviously not a sound expert, but I hope you can get it.
Cool. Now, I happen to know one little detail that I bet Berlin noise load. No, that's not what I need. What do I know? And load value. No. Pin type don't match. Okay. Variable seed. It's an int 32. Okay. Wait, hold on. Random int. Okay, that's what I need. I need this to be there. You go away. I don't think that's working. Oh, it's not actually playing the sound.
An idea. I'm obviously not a sound expert, but I hope you can get an idea how powerful this is. So it's close enough for me. Back in our run animation, we can add a new notify.
Run. God, what song was that? I gotta find that song. It's a song that's just like, it's got music going or whatever, and then all the music stops for a couple seconds. It just says, run. And that music kicks back on again. I don't remember what it was, though. I'll find it later.
So let's stop this for a second. Now we can do a right click, add notify, and then play sound. When we select this, you will see that our footstep is already selected. That's because I still had it selected. And select this, you will see that add notify.
Right click, add notify. Why are you not? Why are you not? Brain? Why is there no right click, add notify? Did you notify? Right click, add notify. There we go. Okay.
And then play
sound. Add notify, play sound. But I want you to be here, but... Oh! Okay, I think I see. Wait, how did you add an extra track?
Can add a new notify.
Oh, there we go. Add track. There we go. Okay, that makes more sense. Add notify. Sound. Perfect. Add notify. Sound.
Track. So let's stop this for a second. Now we can do a right click, add notify, and then play sound. When we select this, you will see that our footstep is already selected. That's because I still had it selected in the content drawer. So, and this is how it sounds like. So let's add a second notify with the other feed, place it properly. When we play in game, we can see and hear.
I think my timing's a little off, but I don't care at the moment. I'm so brain fried, I'm done.
Around. And when we...
I am 2 hours past where I wanted to be.
Spawn some orbs. As we use the same body. You can...
Oh yeah, because... he'll make little sounds too, huh?
Now here both bots running around making noises. Isn't that lovely? As a last touch for this project, let's shake the camera a bit. We go to the effects folder and there we create a new blueprint class. This time we look under all classes for camera shake base. We will add this
base. Effects. Blueprint. Camera shake base. Oh.
And call our ones just simply camera shake. When we open this up, we have some properties we can change. First, we pick Perlin noise.
Root. What? Where are you? Root shake pattern. Root shake pattern. Okay. They're over there. Oh, I'm in. Got it. Okay.
And then we will tweak the amplitude and frequency.
Okay, it already
in a
is
second,
Perlin.
but let's open timing first. We reduce the duration to something very short. And we also decrease the time to blend in and out of the shake. So, for example, something tiny like 001 and 005. For the location amplitude, we do an 8, and the frequency, we do 12 for now. Let's save that.
12.
I want to play it on the door, so when the door opens or closes, we want the earth to be shaking. After selecting the door, I press Ctrl B to find the asset in the drawer.
Ooh, Control B. Hotkey learned. I'll forget it later.
Or in the event graph here, where the door gets
Event graph, okay.
moved by the timeline, we can add play world camera shake.
Play world camera shake.
We select our shake and we need to define where the location of the
Camera shake
epicenter is. So to do that, we want to do it where the door is. So we do get actor location and then plug that into the epicenter. We can specify the radius. This is felt by, and we increase this to a very high number. And hit save. And let's felt by, and we increase this to a very high number. And hit save. And
10,000
looks like when very high number. And hit save. And let's see how that looks like. When we now run around and trigger the door, the camera shakes. A pretty heavy door we have here. And that's it. We made a tiny...
What the heck? Something just bugged out. But there's the camera shake. Oh, wait a second. I just realized that. Why am I... I'm in a very small window. Standalone. Oh. Why did it go into that? Weird. Okay.
Game touching a lot of different in Unreal Engine 5. We imported a static mesh and textures, we made different materials, we used high polygon rocks, created a character, set up his animation, added an AI, and did some game logic, spawning and collecting orbs and adding an interaction component to trigger a door. We made some dust, we generated sound, and I can imagine this is a very good start for a small puzzle game. We used assets from our own StegoBot sample you can download on the marketplace. A lot you learned here can also be found in that project. It's a great place to start if you prefer learning by tinkering. If this isn't enough for you, I recommend you check out our new starter game, Lyra.
We hope this will help you getting started and looking forward to see what you will create in Unreal.
Test, test. I should be back. I didn't even realize the stream crashed. Though, realistically, I probably should have left it stopped for a minute, because I gotta figure out dinner. I have no idea where it stopped. Oh, no, actually, I kind of do. Unfortunately, I think it crashed as soon as I hit play with the screen shake. Because it was like, that's weird, I heard an error ding, but I didn't know where the error ding was. Now I know it was the stream crashing. But, yeah. So it was working. It did work. We have a little camera shake, and I already went through this, but apparently I was not streaming. Yay. But yeah. Camera shake. Anyway, thanks everyone for hanging out, as always. Be well, be safe, be yourself, be kind, be all the good things. Have a great rest of your day.